Within the last few minutes, NASA's Mars polar lander should have arrived at its destination, the southern cap of the red planet, and by NASA's account, if everything went well, the spacecraft landed just moments ago. And CNN's John Zarella is with some of the scientists who are monitoring this very closely at University of California, Los Angeles. John.
Sonia, the science team here at UCLA at the Mars Science Operations Center, all they can do, all the engineers can do now is wait within the next 15 minutes as everyone is gathered around waiting for information. That is when they expect to hear the first signals from the polar lander. What you are seeing are pictures from Mission Control. The mission team there, NASA Administrator Dan Golden sitting there with his hand on his chin. Golden is there along with John McNamee, who was the program manager. And all they can do now is wait. Nervous anticipation, excitement. If polar lander is on the ground safely, it should phone home in the next 10 minutes or so. That first signal, perhaps an image to follow a little bit later, an hour from now, the first downlink of data, and those first fabulous images of the South Pole of Mars, close up as never before seen by human eyes. And then later today, even more images as they begin to build a panorama of the landscape surrounding the landing site. We're going to try and find out exactly where that vehicle landed as we get closer and as they know that it is on the ground safely. Again now, just hold their breath time, wait and see. This is John Zarella reporting live from UCLA. Sonia?
John, thanks so much. Well, that's all for this edition of World News, but Q&A is up next, and they'll be following the Mars polar lander, and within that program, of course, it should phone home, so we want you to phone in your questions and email and, of course, fax us. But for now, I'm Sonia Rusra in Washington. Q&A is next.
Scientists eagerly await the first signals from the Mars polar lander. What do they hope to learn from our distant neighbor? And how might it impact us here on Earth? Hello and welcome. I'm Melita Vasilova sitting in for Riz Khan. The Mars lander touched down on the red planet a short time ago. The landing ended an 11-month, 720 million kilometer journey for the spacecraft. The first transmissions from the probe could reach the Earth just minutes from now. And a little later in the show, we will speak with journalist and author Joel Achenbach. He's written a book that not only details the search for life on other planets, he also asks why so many people seem to need to believe that such life exists, despite any solid evidence. But first, we will be joined by CNN's correspondent John Zarella. But before that, we will listen to some NASA commentary in California, where they're monitoring and waiting for the first callback from the probe. Let's listen in.
Guys, do me a favor again and turn around. Press button 1 on that box, please.
On NASA TV, we see the mission support area at the Jet Propulsion Laboratory. Partially out of frame, lower left is Dr. Sam Thurman. He's a flight operations manager.
And our correspondent John Zarella joins us now. John, so far it's quiet. What's the feeling there?
Hi, Relitza. You can hear me okay?
Yeah, I can hear you okay. What's the feeling there?
Well, the feeling right now is, as you can see, people standing behind me, fingers crossed, just nervous anticipation. Everyone just waiting to know in the next couple of minutes, you know, whether the polar lander is successfully on the ground. It would have landed roughly 35 minutes ago now, but it takes about 40 minutes for them to get the signal back from Mars to know if polar lander is in fact in one piece, is on its 3 legs, is in the right attitude pointing towards Earth. And I want to tell you, Relitza, that we are very pleased that Ashwin Vasavada is taking a minute or two from UCLA, planetary scientist, to talk with us here. And what's so important about Ashwin is that he is one of the team members who actually helped pick out that landing site 165 million miles away or so. How did you find that site? What made you go where this lander is now?
We wanted to go to the South Pole. We wanted to explore somewhere we've never seen on Mars. We've landed near the equator. We've landed in regions that look like volcanic dry riverbeds like in Hawaii or kind of things like that. And we wanted to go somewhere completely different. It's like going to the Sahara Desert on Earth a few times and then going to Antarctica. We're going to the Martian Antarctic. We want to look for ground ice. We want to look for features that might tell us if there's recent climate change. And we wanted to choose a site that would reveal that to us.
Now, you and your team do the best you possibly can to pinpoint the exact landing spot, which is not directly at the South Pole. But now, once you start to get some pictures back today, hopefully later today, then you and other members of the team will then have to tell the NASA scientists and engineers exactly where they are on Mars. That's your job.
That's what one of the things I'll be working on. What it requires, though, is a nice horizon. We want to see little mountains on the horizon, craters, features that we can see from orbit. So we can take the pictures we get from the surface, figure out where we are from the horizon, and then pinpoint it on a map and tell the engineers this is where we think we are. And they're going to be telling us the same thing. They've tracked the spacecraft, and they'll be giving us their best estimate of where we are. And so we're going to compare notes and pinpoint where we are.
And how long will that take?
Well, if the horizon is just a flat, like looking at the ocean or something, it could take a while. We got to find out, we have to have something that's going to give us a clue. So if the pictures are good, maybe today, maybe tomorrow.
What's going through your mind right now? I see there's all kinds of folks here that are members of the mission team just standing around and obviously very, very nervous. What's going through your mind as you're waiting these last few minutes? The clock can't tick down fast enough, can it?
I just can't wait for that moment where we get the signal and then we can just breathe a collective sigh of relief. I mean, the spacecraft has landed. That's the weird thing. Because of the light time from Mars, it's there. And we just need to wait for that electromagnetic signal to get to Earth and receive it and then jump up and down. So I'm really nervous, but our fate is already sealed, which is interesting.
Yeah, there's really nothing you can do at this point. Either it's there in one piece or it's not.
Exactly. And I'm hoping it's there. I'm hoping the solar panels are deployed. Camera's going to pop up. We'll get the pictures. It's going to be a wonderful day here for the rest of the day.
Ashwin, thanks very much. I know we're going to be checking back with you during the course of the next day or two to find out exactly where on Mars you guys have put this vehicle down. And again, you can see all of the folks standing behind me here. Really just a tremendous degree of nervous anticipation as they wait for word. This is the science team at UCLA at the Mars Operations Science Center. And for the next 3 months, these people, 132 plus scientists, will be working from here, analyzing all of the data that comes back from the imagers on board the vehicle and from the soil analyzer, from the robotic arm that will be picking up the soil samples, from an instrument that may record the first audio ever from another world. That too would be coming back, Relitza. So lots of fascinating science to come in the weeks and months ahead. Of course, that all depends on whether the vehicle is on the ground safely, and it is now just a couple of minutes away. Relitza.
John, thank you very much. And as we wait for the Mars Polar Lander to tell us if it's there intact or not, let's take a short break. We'll be back with your questions.
What we expect to hear would be the wind, and potentially, because there are dust storms in the area during this season, it's possible we might hear something like thunder.
Welcome back to Q&A. The NASA Mars Polar Lander should have landed a short time ago. The first mission could reach Earth. The first transmission from it could reach Earth in a few minutes. And I want to tell you that we're watching live pictures from California, where scientists are eagerly awaiting that first signal to find out if the Mars Polar Lander landed successfully or if it crashed and something went wrong. We're hoping for the best, of course. With me here is our guest author, Joel Achenbach. Mr. Achenbach's latest book is called Captured by Aliens, The Search for Life and Truth in a Very Large Universe. He's also a reporter with the Washington Post newspaper. In his book, Mr. Achenbach looks at the quest for extraterrestrial life and why so many people want to believe that life exists out there somewhere. Let's get right to some Q&A. Joel, thank you very much for joining us.
Well, thank you.
Are you caught up in the excitement, or I would say the nervous tension right now?
Oh my gosh. I was just thinking, I wish Carl Sagan could be alive for this moment, because not only would he be able to explain the science of it, he'd be able to explain the significance of it, why it's so important to us. And he certainly was someone who always resonated with this quest for life beyond Earth.
Why was it so important to him?
Well, his whole life he wondered what was out there. And this is a real question, I think, for all of us right now, is what is alive out there? I mean, we know that the universe is very, very large. I mean, it's mind-boggling. But we don't know what the biology is. And so this is probably one of the biggest unknowns in science. And when I wrote my book, what fascinated me was that we tend to make all these stories up, these narratives about aliens zooming around, and sometimes in our stories the aliens come to Earth and abduct people, and there's all kinds of elaborate conspiracies. So it's a very rich topic that clearly has a deep cultural imprint on us right now.
You mentioned what the biology of other forms of life could be. What do you think that we might find on Mars?
Well, I tend to be kind of a curmudgeon on it, I have to admit, prematurely curmudgeonly. I think we're probably not going to find life on Mars. The cynic might say that life is so appealing to us that it's a great way to package these missions. That said, though, there are people who I interviewed in my book who do think that life could be there right now in these aquifers deep beneath the surface. I mean, it's a very, very big debate. I think if you look at the history of the idea, people tend to overestimate the abundance of life and how easy it will be to find it. I mean, a long time ago, people thought it might be on the moon. They thought it might be in the sun, even. They thought that Mars or Venus could have life. And I remember growing up reading about these waves of darkening on the Martian surface that some people thought might be vegetation. If you look at Mars, I mean, it's a fascinating place, and I hope that thing is there safely. I'm as excited as anyone else, but it is a desolate place, and it raises the question of, well, why is the Earth so full of life, and why are these other planets like Mars apparently such desolate places? What is it that causes this phenomenon where there's so many ways to be a dead planet, and apparently not that many ways to have a planet with life on it?
Will it help us figure out a few environmental problems and what we need to stop doing here on this planet?
I do think that people, when they look for life out there, need to constantly look back at ourselves and realize that we may be very lucky. And I don't think we're necessarily alone. That's just my guess. I have to think that life is probably out there, and maybe intelligent life. But the Earth may be a fairly special place, a fairly rare place where there's life, there's liquid water splashing around at the surface. You look at our solar system, and there's a lot of dead places out there. And we found some new planets recently orbiting these other stars, but these don't look like the friendliest of solar systems. So you begin to wonder if, in fact, intelligent life, for example, might be fairly rare, at least in our part of this galaxy. And these are the kind of things I go into in my book as I follow people around who themselves are obsessed with this topic.
You have talked to a lot of people. What are the most outlandish claims that you have heard?
Well, some people thought that I might be an alien. In fact, I was hypnotized very briefly in an attempt to see if I could remember being abducted, but I failed very badly at that. I couldn't remember any alien encounters myself. There is a very powerful belief out there that aliens have come here. There are some people who are in my book, and they're good people, but they think that they themselves are aliens. They have alien spirits in their bodies. And I kind of explore, well, how did this idea develop? To me, it's kind of a heresy of modern astronomy, in which we know that space is huge. We know it's conceivable for intelligent creatures to travel in space, because we've done it. So, well, maybe they've come here, and that's where the idea begins, and then it just evolves. And lately, there's these ideas of alien conspiracies to create hybrids of aliens and humans. So there's some outlandish ideas.
Joe, we'll continue our conversation in a moment. We want to go to our correspondent, John Zarella, and see what he has to say from what's happening in California. Let's listen in.
Relitza, I can tell you that they are waiting now for data from the spacecraft. They're about 5 minutes into the opportunity during which they would have received information. That does not mean anything is wrong. It just means that perhaps the Earth antennas at Goldstone have not locked onto the signal yet. It could mean that the vehicle has safed itself in a safe mode because it's had some problem and is running through a cycle of checks and balances on board the vehicle, at which a little later in the next 30 minutes or so would be another opportunity for the vehicle to contact Earth. And you know, even if that should fail, there is also an opportunity to go through a relay by literally bouncing a signal from the spacecraft to the orbiting Global Surveyor satellite which is orbiting Mars, use that as a relay back to Earth. So still many opportunities. It's important to remind people that the unbelievable success of Pathfinder a little over 2 years ago, when the signal came back so strong and clearly, is, you know, it was just an anomaly that they didn't expect to get so much information so quickly from Pathfinder, so it should not be expected this time. So again, the mission management team, the engineering team just waiting. Here at UCLA, the science team gathered around, fingers crossed, arms folded, just staring and waiting, waiting for word from the folks, the engineering team at JPL, that they've received that signal. It has not come yet, but still not time for anyone to get too terribly concerned that something is wrong. There may be nothing wrong at all. Relitza?
How difficult is the landing?
It is a tremendously complicated process of pyrotechnic events. You have a spacecraft that's descending at 15,000 miles an hour through the Martian atmosphere. As it moves through the Martian atmosphere, it has a heat shield, it has a back shell. The back shell has to come off. The heat shield is used to protect it as it descends through the atmosphere. Then a parachute deploys, then the back shell comes off, and then the legs of the lander, the 3 spindly spider legs are extended out. Then retro rockets are fired as the vehicle comes down, and it is coming down at a speed of only about 5 miles an hour when it finally touches down. And of course the hope is that it touches down on all 3 of those legs in proper position. So it is a terribly difficult procedure. The Viking landers used the same procedure to land. That was not how they landed with Pathfinder. On Pathfinder, of course, they used airbags to bounce on the surface and roll to a stop. That was a technology demonstration, very different than anything that had ever been done before. So this is more of a typical planetary landing on Mars that they did, you know, 20-some years ago on Viking missions. But it's still the number of pyrotechnic events that it takes to do it properly. Anything can go wrong. Hopefully nothing has gone wrong here, but it is literally now just waiting and crossing of fingers because they have not heard from the vehicle. Relitza?
So when they hear from it, in what form will that signal be?
It'll literally be like a telephone signal back. It could be simply a dial tone that they hear, carrier signal, and then eventually they will start getting data back from the polar lander, and then that will be coming down in a stream of data information, and then images, pixels, little tiny pictures, mosaics of the landscape, because that is all automated, all pre-programmed for the vehicle to begin sending those back. And those first images could come back within the hour. You might see a shot of one of the footpads, one of the legs on the surface, could be a shot of 1 pixel from the horizon. It just depends on how much data they can get back on the feed and exactly what the vehicle has taken images of, as well as status. It will send back information. The key information that will first come back will be information on the health of the vehicle. Is it in complete working order? Are there systems that are not working? Are all the systems working? And that's what the engineering team wants to hear from the vehicle. But again, they're just waiting now, and no word from Polar Lander. Relitza?
John, we'll go back to our guest, Joel Achenbach, who has written the book Captured by Aliens, The Search for Life and Truth in a Very Large Universe. Joel, does this make the case for a manned mission probably to Mars? It's very complicated to monitor and to direct and control everything from Earth. So does this make a case for trying to have a manned mission one day?
Well, it's hard to go there, obviously. I mean, I hope that spacecraft, that lander, sends a signal in the next few minutes. A manned mission has the problem of life support. I mean, it's dangerous to do it. The people who are advocates of going make the point that we have to accept risk in our civilization the same way people did in the past, when the pioneers, when they explored various frontiers, the oceans, you know, Antarctica, that kind of thing. A lot of risk is involved. I personally think some people have been a bit overwrought in their rhetoric, saying we need to colonize Mars and turn it into a new world. I'm not sure that's necessary. Also, it's technologically, it is very tricky to do it. As we can see with these kinds of missions, a lot of things can go wrong.
We have a question via email which came to us from Asker in Saudi Arabia. The question is, do you think that the millions of dollars spent on this mission could have been better used elsewhere?
I think, no, I actually think this is a wonderful mission. I think finding knowledge about the universe is a very noble thing. In fact, these are relatively inexpensive missions compared to missions in the past. This is not some billion-dollar Battlestar Galactica, as Dan Golden, who's the head of NASA, a term he likes to use. This is a relatively inexpensive mission compared to ones in the past, and I think we should find out about life in the universe. So I have no problem with spending money on this. I'm clearly, in the long term, as we go out into space and as we find out about life or search for life out there, we're going to re-examine ourselves and I think maybe renew our interest in this planet and this civilization and maintaining our own world, because a world like the Earth may be very, very rare.
What is the significance if everything goes well and if they find traces of water?
Well, keep in mind, we've never found, not only have we not found any sample of extraterrestrial life, we have not found any liquid water off the Earth. Okay, so this is important to find out what's out there. I think, unfortunately, this current mission is not going to solve a lot of these mysteries. I mean, for example, we're not going to find out if there's life on Mars with this particular mission. It's part of a many-tiered process. In fact, we may not find out that answer for a long time. I think we often overestimate how easy it is to get the solution to this whole riddle of extraterrestrial life.
Joel, I'm turning here to our chat room where one of our viewers asks, he of course identifies himself from Earth. Our viewer from Earth says, what will this mission tell us about Earth?
Well, our understanding of the solar system is gradually letting us understand what the history of planets tends to be. I mean, if you look at if you go back 4 billion years, Mars may have been much warmer and wetter. We want to find out what story Mars has to tell, because bad things happen to good planets. It appears that Mars and Venus both went through these very dramatic changes where they may have gone from being planets that had life to being planets that apparently are totally inhospitable to life, or at least where life would have a very difficult time hanging on. So I think this question of, what happens to planets over time is an important one if we want to know what's out there in the universe. What is the norm for a planet? In our case, our planet has remained habitable apparently for about 4 billion years, and that's a very interesting thing. How common is that?
We have a question via email which came from France. Question is, what are the first contact procedures in case we do establish contact with an intelligent alien species? Who has defined these procedures and how are they to be implemented? Quick answer.
I think what will happen is the various talk radio hosts will immediately send out their own response, and there'll be mass confusion. There is a protocol in which, and I don't know the exact order of things, in which the international astronomical community shares the news. Leaders of major world powers are informed, and ideally there's supposed to be sort of a discussion about how to reply. I don't know that it'll actually go down that way. And in my book, I talk a lot about this idea of SETI, the search for extraterrestrial intelligence. And I spent some time in one of these big telescopes in the middle of the night out in the middle of nowhere of West Virginia waiting for the signal. And it tends so far, you know, all we get is static. And that may just because we haven't tuned in the right channel yet.
Joe, thank you very much. Joe Achenbach, thank you very much for speaking with us. We go now to John Zorell in California there with the scientists to give us an update. Have they heard anything, John?
Relitza, still not yet. Still waiting. Still waiting. Once they get past this initial opportunity to hear from the vehicle, you can probably see there the mission team is just huddled. That is at the Jet Propulsion Laboratory. Again, all they can do is just wait. But once they miss this initial opportunity, they'll have to wait about another 45 minutes to an hour.
So what is the
next opportunity?
What is the window until all hope is gone? How long can they wait?
Oh, they can wait many hours into late this afternoon or evening, because again, if they cannot contact the vehicle now, if they cannot contact it on the next opportunity, then they would go to a backup plan, which would be late this afternoon or evening, where they would try to contact it through the orbiting Mars Global Surveyor satellite. That would be the next opportunity late this afternoon. And they would continue trying to contact it probably for several days to come. They're not going to just give up because they don't hear from it now. There could be lots of different variables for why they are not hearing from it. Again, this is not necessarily unusual. We may have been spoiled a little bit by the success of the Mars Pathfinder a couple years ago. So we just have to, everyone collectively holding our breaths here and at the Jet Propulsion Laboratory. Relitza?
Well, we'll leave you holding your breath. And of course, CNN will bring you the latest as soon as we get any word from any signals coming from the Mars Polar Lander. A reminder that Joe Achenbach, the author we were talking with, will be taking part in a chat room discussion after this show. Of course, you're invited as well. To get to our chat room, visit the website at cnn.com/Q&A. And there you'll find the link to take part. The next edition of Q&A will look at life in Afghanistan under Taliban rule. Our guests will include the former United Nations envoy to Afghanistan, as well as a Taliban representative in the United States. For now, stay tuned. The news continues here on CNN.
Laboratory in California, a news conference underway there. Let's listen in.
Communications, but as I said, it wasn't unexpected that we wouldn't hear from it. And as you will recall from this morning's discussion, we have a plan of additional communications opportunities today. The next one starts in about a little less than 20 minutes now, and we expect that will give us a good opportunity to again get communications. And if we can look at the first slide, we will also see that there's another opportunity tonight at about 8:10 p.m., which will be our next opportunity beyond that. In both of these situations, the spacecraft will do an MGA search. As you will recall from this morning, I said that a very critical aspect of the initial landing phase was this gyrocompassing activity where we determine the orientation of the lander. And again, as I said this morning, you know, small shifts in the lander during that activity could potentially cause pretty significant mispointing in the medium gain. And so in both of the 2 o'clock and 8 o'clock tonight opportunities or windows, we're going to try to now command the spacecraft into a search, a raster pattern search. And in both cases, those searches cover a sector of the sky that's about 50 degrees by 30 degrees or 40 degrees. So it's looking over a pretty big chunk of sky, and basically we go from one place to the next, to the next, to the next, and we look at from the Deep Space Network to see whether or not we see a signal from it. So as I said, the first opportunity that the spacecraft will have to do that is at starts actually a little bit earlier, 1:58, but the first point that it uses was the point that it should be on, the place where it thinks the Earth is at, and so since we didn't see it the first time, it's unlikely to be there. So the 2:04 is about the time that we would expect to maybe begin to see a signal. Again, that particular opportunity is associated with a safe mode entry at touchdown. If the lander went into safe mode at touchdown due to a reset of the flight processor, you would expect to see it begin to do this on its own. If we don't see it at that point, then as I said, this morning we'll send a command in the 6:30 to 7:30 time frame this afternoon to begin to do this raster pattern by ground command later this evening. So as I said, this is a not entirely unexpected. Obviously, we're a little disappointed not to see the signal at 12:39, but we prepared for this, and we're going to go ahead and execute our plan as we described it. So with that, I will let Frank open it up for questions.
Okay, great. We'll take Q&A in just a minute. First, though, I wanted to tell you about what we're going to be doing today in terms of our news programming. At 2 o'clock, we're going to come up with NASA TV again with a live feed during the communication opportunity from about 2 to 2:45. And then we'll be back this evening from 7:30 to 11. That is both a communication opportunity for Mars Polar Lander and also the period of time in which we might hear from the Deep Space 2 microprobes. We'll end the evening with a press conference at 11:30 with the status of what we know at that point. With that, he's got to get back to work, but we'll take a few questions. Seth?
If you hear from Deep Space 2 and not MPL today, or if you don't, what does that tell you anything, and what does it tell you? Or if you hear from neither today, what does that tell? Does that give you any information more on when you start worrying?
No. I mean, it really they're so separate in terms of the things that have to have taken place. Clearly, we saw the turn. You know, that's where we get to the right entry attitude. We saw that begin, and so that's not. You know, that's kind of the very last point, other than cruise stage separation, where they have a connection. I think that MGS and the Mars Relay and Deep Space 2 will just kind of go along its path. We're going to, you know, obviously the reason for having a plan, a well-thought-out contingency plan, is we don't want to start, you know, reacting and using the relay and doing things without, you know, having some discipline for that in that process. And so we're going to go along the steps as we identified them, because that's what our engineering and design said was the right approach.
Bill?
Bill Harwood, CBS. How long does it take the medium gain antenna to complete an entire search pattern, assuming it doesn't lock onto anything in the meantime? And also, can you be a little more specific about what level of settling translates into a degree of aiming error with the MGA?
It's to answer the first question, it takes 45 minutes to an hour. The one the first one this morning is about 45 minutes long, and the second one, if we command it, is actually more like an hour. It's a little slightly larger. And so that's the difference. The settling, we're trying to quantify exactly what the number is, but it's a small number. I mean, it's millimeters, kind of a settling into the ground. And so, I mean, and that's one potential reason for it, is not just settling, but if you had, you know, some sort of a shift as you were touching down, that's another example where you could have a problem. So there's a set of things that could have caused a gyrocompassing problem, all of which would be fixed by us doing this pattern search.
Let's take one from Leo here.
Leo Enright from Irish Television. Richard, I'm just wondering, you seem to give, I won't say give up, I don't want to give the wrong impression here, but you did seem to stop fairly early in the communication session just now. You seem to say, right, well, look, we're all going off and having a break. I mean, you were certainly no more than halfway through the communication session when that decision was taken. Will you do the same on the backup downlink opportunity? I mean, do you reckon that if you haven't heard from the spacecraft in the first, say, 10 minutes of the opportunity, that you're not going to hear from it in that session? And I assume it's different then when you go into this rastering motion, because obviously you'll be listening out all the time. But am I right in thinking that at this next opportunity, you'll repeat what you did on landing?
Well, when they released some of the people to go off console, those were mostly the subsystem engineers on the spacecraft team. The ACE, the real-time operations person, and the DSN network operations engineers, who are the key people for monitoring and looking for a signal, were there looking for it all the way through. So it's the people who would then use the data after you got telemetry down that we let go off console just to take a break. So the key people were there the whole time, and they will be there the whole time through this next session as well, as will the telecom engineers, who are also integral to the performance of the link between here and the spacecraft.
We have two news media questions from Lockheed and Denver. We'll take those.
Hi, this is Rebecca Cantwell from the Rocky Mountain News in Denver. I'm wondering if you can give us any sense of probability of how confident you are at this point that everything is fine, and conversely, how worried are you at this point?
Well, you know, I can't come up with a number. I'm very, as I said this morning, this is not an unexpected thing. I'm very confident that the lander survived the descent. As you saw from our discussion prior to landing, we had a very accurate entry, right exactly on the desired entry corridor. Everything looked very good. So I think we're a long way from getting concerned.
One more question from Denver.
Ann Schrader with the Denver Post. My question to you is, at what point do you start having a dwindling return on the probability that it's okay in terms of the communication? You get to Saturday, you get to Sunday, when?
No, it's actually beyond that, not for several days. We have a number of opportunities, as I described in that discussion from this morning and from yesterday, that we have opportunities on Sunday, we have opportunities Monday. It goes on for quite a while, and I think we would not, we don't plan on giving up anytime soon.
Okay, back to JPL. Thank you.
Conan Nolan, KNVC. Richard, 97, you were in that room when Pathfinder's carrier signal came in. It seemed like that mission went perfectly. Is that a problem here, in that the public perception is that you should be getting this kind of telemetry back immediately, and the bar was raised from that mission?
I don't know if the bar was raised. I mean, we always expect to do very well, and so you know, this was our first opportunity. We expected to get it because we designed the spacecraft to do that under most circumstances. In a way, on Pathfinder, we had some good fortune in that we landed completely upright and got the carrier back right out of the gate. And so in a sense, yeah, maybe we were a little fortunate, but I think that there's not that much relationship between that and this time around.
We'll take Mike and then Kathy.
Yeah, Mike Dornheim with Aviation Week magazine. Rich, do you have a sense from the last navigation update, what the most recent one, where you were in the B-plane essentially? And then a second question, do you ever use the LGA, the low gain antenna, in the X-band? When does that come in?
Okay, I'll ask the first question. I don't want to be precise on the numbers. We can get you that afterwards, but we were just a little bit shallow, about 2 kilometers in the B-plane shallow, which is around 1/10 of a degree. And I'm not sure the exact number, but we can, like I said, we can get it. As you saw from the discussion that was going on in the conference room there, we were more or less, you know, we understood exactly where we were, and we were almost due south of the target at around 1/10 of a degree shallow.
And that was the last and best?
Absolutely.
Okay.
Yeah. As to the other question, I'm trying to remember. Oh, the low
gain antenna.
The low gain actually is receive only.
Oh.
So you cannot receive through you cannot transmit through the low gain. So you can only transmit through the medium gain antenna, or then through the MR UHF system.
All right, we've been listening there as the Jet Propulsion Laboratory lays out their perspective on events taking place right now on the surface of Mars. Still very confident about putting another Mars spacecraft there on the surface of the red planet. After all, it was just 2 years ago that the probe called Pathfinder, with its Sojourner robot, successfully landed on the surface and brought us spectacular pictures from there. Donna Shirley was the former manager of the Mars exploration program, the original leader of the team that built the Sojourner rover. She joins us now from Pasadena, California. Well, once again, here at one of these exciting times in the history of space exploration. What's the mood there?
Well, the mood is, there's actually a rather festive mood here for the Planet Fest. Everybody's having a really good time at the Planetary Society's big event, which goes on for 3 days. But the mood at JPL is very tense, and around here some people are pretty tense too, because we would like to have heard from the lander right away, and we didn't. And so now there's a number of opportunities. The engineers are working hard to find the right frequency, to maybe send some commands to the spacecraft to tell it to scan with its antennas so that we have a better chance of picking up the next signal. And as I understand it, the next attempt is about 2:04 this afternoon. That's Pacific time.
All right, so there's not much longer to wait for that second attempt, but how anxious should people really be, or does this require some patience?
Well, it requires patience because, see, Pathfinder spoiled everyone. Because Pathfinder, we got that signal immediately because the lander was lucky enough to land right side up, and this little thumb-sized antenna was able to transmit the beep that said we're here. Now, that has not happened with Mars Polar Lander because it took actually some more complications. They had to unfurl an antenna and so on in order to get that first signal back. So there are more things that can go wrong with that initial signal, and there's a lot of possibilities, and most of them are not catastrophic at all. Most of them just have to do with small adjustments in either the frequency or the direction that the antenna is pointing.
One thing that always perhaps surprises, amazes people on the outside of the space exploration field is the amount of enthusiasm that yourself and others bring to it. Why do you have such a love, if you will, for the red planet, for reaching Mars, for solving some of the mysteries about it?
Well, I mean, how can you not want to go out and have adventures in unknown places? It's wired into us genetically. Watching Star Trek movies or Star Wars movies is all about the excitement of exploration, and here we're really doing it. It's vicarious, but it's less vicarious than a movie because we actually are sending something that we built that represents humanity. It's an ambassador to the surface of a planet that maybe one of these days humans can visit, and that's pretty exciting.
What do you think can be found by this probe on that planet?
What this probe is designed to do is to look for water. Now, people don't think that sounds very impressive, but we actually have no idea how much water is in the soil on Mars and what kind of water it is, how much of it there is relative to dry ice. We know there's ice because Viking saw it from orbit back in the 70s, but we don't know how much. And the Viking landers tried to measure water, and there was more water in the soil than they could measure, and so we have no idea what that is. Now, water is the key to what happened to the Mars climate. Why did Mars turn into a dried-up ice age planet when it used to be warm, wet, and friendly? Things like, could that happen to the Earth? We'd like to understand what happened to Mars so we could know maybe what we might be doing to the Earth and what we could do to the Earth. The other thing is to prepare for future human missions. Future human missions are not going to be able to take all their water. They're going to have to find water at Mars, and so we'd like to know where is the water. And finally, if there ever was life on Mars, it was probably connected with water. So we'd like to understand how the water was, where it might be today, so that we can look for signs of past life.
From a scientific perspective, do you think that manned missions are absolutely essential, or should the technology for these kinds of robotic missions to Mars be what is immediately ahead?
Well, first, let me pick on the term manned. I like to use the term human, because there's a lot of Eileen Collins, for instance, would say that these are human missions.
I conceded.
Attaboy. And I think that human missions are important for us as a species because of this need to explore. I think if we don't explore, we're going to dry up and you know, turn in and kill ourselves off and things like that, which sounds a little alarmist, but that's kind of what's happening. We're getting overcrowded, we're getting overpopulated, people are starting to go into more extreme sports, they're looking for adventure, and it's just wired into us to do that. So I think human missions to Mars are going to be necessary for us as a species to have that kind of goal for ourselves and that kind of outlet for exploration.
Salve for the soul, a mission to Mars.
Exactly.
We still have to wait and see what the outcome is going to be in the hours ahead. I am sure that you're going to be watching there, as well as all of us from here at the CNN Center and all around the globe, really, to find out what's next in this mission, and hoping for the best. Thanks for being with us.
Thank you.
Well, that must be insight for this day. I'm Jim Clancy. We're glad that you could be with us. Stay tuned to CNN. We'll have more on the Mars coverage in the hours ahead.
10 seconds after
Tension
that.
was high, but so were spirits as the Mars Polar Lander reached the end of its 450 million-mile journey. munching peanuts for good luck, a landing day tradition at NASA's Jet Propulsion Lab. They joked when they saw precisely where the 13th U.S. mission to Mars was headed.
I wish very much I could show you the piece of real estate we're headed for, just shown to us by the project scientist. It's, well, pretty bland.
That sounds great. Hold it up to the TV. We're watching it.
But the room became silent very quickly when the polar lander did not phone home during its first communication opportunity. Not a huge concern, not even a surprise, given the vagaries of communication across 157 million miles of space.
There's nothing to be seen at this time.
Little more than an hour later, they tried again. This time, the dish-like medium-gain antenna programmed to conduct a methodical search for Earth, a cosmic needle in the void. But after 45 minutes, still no joy.
Obviously, we're a little disappointed not to see the signal at 12:39, but we prepared for this, and we're going to go ahead and execute our plan as we described it.
All of it is starkly reminiscent of the scene here 10 weeks ago when the same team lost the lander's sister ship, the Mars Climate Orbiter. The lander was to use the doomed orbiter as its communication relay to Earth, but now will use the Mars Global Surveyor, already in orbit around the red planet. But the polar lander cannot use that communication path until a pair of 6-pound microprobes, which hitched a ride with it, get their chance to phone home.
We're giving priority to those penetrators for 24 hours after they've hit the surface. They've been down on the surface now for several hours. And tonight, around 9 p.m. Eastern Time, we will listen, communicate with them, get their data, and then we'll have the system available to communicate with the lander.
Anytime NASA sends a probe to another planet, the risks are great and the stakes are high. But the ante was upped after the loss of the Mars Climate Orbiter, and nothing less than the underlying philosophy of more frequent, cheaper missions is on the line. Miles O'Brien, CNN, Pasadena, California.
There was utter silence in the room. Mission scientists nervously munched peanuts, a 30-year-old NASA good luck tradition, and waited for the first signal that the Mars polar lander was safely on the surface of the red planet. But scientists at the Jet Propulsion Laboratory in Pasadena, California, and the Deep Space Network heard not a sound from the spacecraft's medium-gain antenna.
Obviously, we're a little disappointed not to see the signal at 12:39, but we prepared for this.
As NASA animation demonstrates, the lander was supposed to parachute through the Martian atmosphere, separate from the chute and back shell, and use 12 rockets to ease the craft onto the planet's surface at about 5 miles an hour.
I'm very confident that the lander survived the descent. We had a very accurate entry, right exactly on the desired entry corridor.
Solar panels were then to unfold, the antenna point toward Earth, and send the first signal and perhaps a black and white image from one of its cameras. Mission experts could not be sure if its failure to do this meant there was a correctable problem of antenna alignment or a catastrophic failure.
We have opportunities on Sunday, we have opportunities Monday. It goes on for quite a while, and I think we would not, we don't plan on giving up anytime soon.
The polar lander mission comes after the September loss of the Mars Climate Orbiter due to a navigation mistake. The orbiter was apparently destroyed, crashing or bouncing off the Martian atmosphere. Scientists of the Mars polar lander can only hope the signal setback is just that, a setback, and the 90-day mission to survey Mars for water will succeed. Jim Hill, CNN, Pasadena, California.
And for the very latest on the polar lander mission, we are joined now by CNN's John Zarella in Los Angeles. John?
Well, I'm at UCLA, which is the Mission Science Operations Center, where 100 or more scientists will be gathered once they finally begin hearing from the polar lander. And they are gathered waiting, as everyone else is, in the final minutes of what is the third opportunity to hear from the polar lander spacecraft. Still no joy, no report from the polar lander spacecraft. It is also the end of the second opportunity to hear from those 2 microprobes which were jettisoned from polar lander just before it entered the Martian atmosphere. The polar lander microprobes descending down at about 400 miles an hour, literally crashing into the Martian surface and then penetrating 1 to 2 feet below the surface. Signals were being sent up to a satellite called the Global Surveyor, which is being used as a relay satellite for those microprobes, and on 2 passes of the Global Surveyor over what is believed to have been the site where those microprobes went down on Mars. There was no signal received. They will now wait again another couple of hours for the next pass, so no joy at that point either. In an effort to kind of lighten a little bit of the tension and that has been going on here in building all night, many of the scientists among the science team held up a sign that they spelled out in letters, Mars Polar Lander, phone home. And of course got a rousing a round of applause for that sign. It broke the ice, so to speak, and of course Mars Polar Lander is landed somewhere on the ice on Mars, hopefully in one piece, and the next opportunity, if this does not work, would be in 24 hours to hear from Polar Lander. Again, no joy, no signal from either the Polar Lander or the two microprobes. This is John Zarrella reporting live from UCLA. Colleen?
All right, thanks very much, John. John waiting along with everyone else for word from the Polar Lander.
Sonde Polar Lander, die gestern auf dem Mars landete, gibt es noch immer kein Signal. Die Mitarbeiter der US-Raumfahrtbehörde NASA versuchten bislang vergeblich, selbst Kontakt zu dem Raumfahrzeug aufzunehmen. Unklar ist, ob nur eine Antenne falsch ausgerichtet ist oder die Sonde womöglich zerstört wurde. Noch haben die NASA-Wissenschaftler die Hoffnung aber nicht aufgegeben. Im September war eine erste Mission zur Erforschung des Planeten Mars gescheitert.
Die NASA-Forscher warten bislang vergeblich auf ein Zeichen des Polar Lander. Er sollte gestern Abend auf dem roten Planeten landen. Möglicherweise ist die Sonde abgestürzt. Die NASA hofft, dass nur die Stromversorgung vorübergehend unterbrochen ist. Ziel der Mission war unter anderem, erstmals Töne vom Mars zur Erde zu senden.
The spacecraft has not checked in since its scheduled landing on Mars on Friday. The U.S. Space Agency says it is not overly concerned about the delays at this point. The lander may have missed its mark or experienced computer problems that can be corrected. Scientists have 2 windows of opportunity to try to communicate with the Mars lander on Saturday.
Und die Frage ist, was ist mit der Marssonde passiert? Nun, im Augenblick ist es nicht so wahrscheinlich, dass sie zerstört wurde, denn die Daten kurz vor dem Landeanflug, kurz vor dem Eintritt in die dünne Marsatmosphäre waren sehr gut. Vielleicht ist sie so gelandet, dass die Antenne abgewandt ist von der Erde, sodass dieser Kontakt im Augenblick nicht gemacht werden kann. Aber diese Antenne ist so programmiert, dass sie selbstständig ihren Weg versucht zu finden, um in Kontakt mit der Erde zu treten. Eine andere Möglichkeit gibt es in einigen Tagen, denn um den Mars kreist schon seit Jahren eine Sonde, Mars Surveyor, und diese Sonde wird dann als Relaisstation benutzt. Das heißt, die Signale gehen von unserem Marslander zu dieser Sonde und dieser Mars Surveyor, der wird dann die Funksignale weiter zur Erde geben. Und unter einem allzu glücklichen Stern stand diese Mission von Anfang an nicht, denn ursprünglich sollten ja 2 Sonden den Mars erreichen. Vor 2 Monaten sollte die Orbiter Climate Sonde den Mars umrunden und sollte dann als Relaisstation für den Marslander dienen. Nun, was diese beiden Missionen zu tun haben und was eigentlich der Marslander dort oben auf dem Mars machen soll, das zeigen wir Ihnen jetzt.
10. Dezember 1998. Start des Climate Orbiter in Cape Canaveral. Während sich die Sonde von der Erde entfernt, öffnen sich Solarsegel, um Strom zu gewinnen. Während seiner 9-monatigen Reise hatte Climate Orbiter ständig Funkkontakt zur Erde.
Am 3. Januar 1999, knapp einen Monat später als der Orbiter, beginnt der Polarlander seinen 11-monatigen Flug zum Mars. Sobald die Sonden das Schwerefeld der Erde verlassen haben, begeben sie sich auf eine Umlaufbahn um die Sonne. Ihr Kurs wurde so berechnet, dass sie den Mars exakt zu einem bestimmten Zeitpunkt und an einer bestimmten Stelle erreichen. So war es zumindest geplant.
Beide Sonden auf dem Weg zum Mars. Im September nähert sich der Orbiter seinem Ziel, der Mars-Umlaufbahn. Von dort aus soll er Hinweisen auf Wasser nachspüren und die Zusammensetzung der Atmosphäre feststellen. Doch ein fataler Fehler gefährdet die Mission. Bei der Berechnung der Flugbahn hatten die Programmierer englische Entfernungsmaße nicht in Meter umgerechnet. Die Folge dieser Schlamperei? Der Orbiter verfehlt sein Ziel, die Umlaufbahn, und stürzt ab.
Der Lander dagegen sollte gestern auf dem Mars landen. Der Trick zeigt, wie es geplant war. Eine Kapsel sollte ihn vor der extremen Hitze schützen, die entsteht, wenn er mit fast 26.000 Kilometern pro Stunde in die Marsatmosphäre eintritt. Diese ist zwar 150 Mal dünner als die Erdatmosphäre, aber dennoch hätte der Widerstand ausreichen sollen, um den Fallschirm zu öffnen. Trotz Überschallgeschwindigkeit wäre der Lander ausreichend abgebremst worden, um dann das Hitzeschild abwerfen zu können.
Welch ein Manöver. 12 kleine Bremsraketen sollten den Flug stabilisieren und die Sonde so aufsetzen lassen, dass sie später möglichst viel Sonnenenergie hätte tanken können. Der Landeplatz liegt etwa 600 Kilometer vom Südpol entfernt, in einer Zone, in der sich das polare Eis aus Kohlendioxid im Winter ausbreitet und im Sommer wieder zurückzieht.
Zurzeit herrscht auf dem Mars Frühling. 18 Monate später ist dann Winter. Kurz nach dem Aufsetzen sollte die Stereokamera eine 360-Grad-Panoramaaufnahme vom Landeplatz aufzeichnen und an die Kontrollstation auf der Erde weiterleiten. Hier im Trick zu sehen. Die Umgebung ist von Sand bedeckt, der gleichmäßig vom Wind verweht wurde. Er hat sich mit Eis vermischt und abgelagert. Dieser Prozess könnte über Jahrmillionen hinweg Schichten geschaffen haben, an denen sich Klimaschwankungen chronologisch ablesen lassen. Vielleicht finden Forscher hier versteckte Hinweise auf die vermuteten Klimaveränderungen auf dem Mars.
Mit seinem Arm hätte der Roboter auf der Sonde Bodenproben entnehmen sollen. Wissenschaftler auf der Erde hätten die Aktionen mit Hilfe der Stereokamera und der kleinen am Roboterarm montierten Kamera verfolgen können. Die Bodenproben wären erhitzt und dann die aus der Probe ausgetriebenen Gase untersucht worden. Deren Zusammensetzung hätte den Forschern wichtige Daten über die geologische Entwicklung des Planeten geliefert.
Gab es früher große Wassermengen auf dem Mars, wie einige Forscher vermuten? Gibt es Anzeichen für Leben? Könnten Mikroben hier überleben? Und könnte diese staubige Wüste je eine Heimat für Menschen werden?
Die Suche nach Wasser ist ja die Hauptaufgabe dieser Mission, denn diese Mission ist ja ein Mosaiksteinchen in weiter folgenden Unternehmungen zum Mars. Findet man Wasser, dann könnte man den Plan weiterverfolgen, eine bemannte Mission zum Mars zu planen. Das Wasser wäre dann für die Crew, aber man könnte das Wasser auch zerlegen mit Hilfe von elektrischem Strom zu Wasserstoff und hätte dann Treibstoff, um zurück zur Erde zu gelangen. Nun, um das Wasser zu finden, hat man auch 2 Minisonden abgesprengt, kurz vor der Landung von Polar Lander. Aber leider auch diese Minisonden geben zurzeit kein Signal. Nun, Suche nach Leben, das ist hier nicht die Aufgabe. Man könnte höchstens die indirekte Schlüsse ziehen. Denn wenn es Wasser gibt, dann könnte auch die Chance für Leben auf dem Mars größer sein. Allerdings nicht die grünen Marsmännchen, wenn überhaupt, dann äußerst primitive Mikroorganismen. Nun, man hat ja schon viele Sonden zum Mars geschickt, vor 25 Jahren ungefähr, die Viking-Sonden. Vor 2 Jahren haben Sie die fantastischen Bilder von Pathfinder gesehen. Und da waren wir ja auch etwas verwöhnt, denn als Pathfinder landete, da gab es sofort ein Signal und wir konnten auch relativ schnell die Bilder empfangen. Aber Hoffnung besteht selbstverständlich, dass auch diese Lander-Sonde uns irgendwann ein Signal geben wird. Und was die anderen Sonden alles gefunden haben, das haben wir Ihnen jetzt einmal zusammengefasst.
Die vereisten Polkappen des Mars. Sie sind von der Erde aus erkennbar. Besteht diese dicke Eisschicht tatsächlich nur aus Kohlendioxid, wie viele Forscher glauben? Gibt es Wasser unter der staubigen Oberfläche des Planeten in Form von Eis? Und wenn ja, handelt es sich tatsächlich um große Wassermengen, wie immer wieder vermutet wird? In Äquatornähe der riesige Arsia-Vulkan. Dieser hier heißt Pavonis. Und hier Askreus.
Aber dieser hier lässt alle hinter sich. Olympus Mons. Mit einer Höhe von 27 Kilometern ist der Olympus Mons dreimal so hoch wie der Mount Everest. Zeuge gewaltiger vulkanischer Aktivitäten in der Frühzeit des Mars. Allein diese Felsen sind 6 Kilometer hoch. Handelt es sich hierbei um Klippen, die einst ein Urmeer formte? Eine immer wieder diskutierte These.
Das hier sind Aufnahmen riesiger Wirbelstürme, dreimal so hoch wie die Tornados auf der Erde. In den 80er Jahren glaubten einige Forscher, auf Marsbildern ehemalige Ozeanbecken zu erkennen. Die Ozeantheorie war geboren.
1997 landete die Marssonde Pathfinder in einem Gebiet, das angeblich eine alte Überschwemmungsfläche war. Die Umgebung wird erkundet. Ein Roboter, der berühmt gewordene Sojourner, macht sich auf den Weg, um die Beschaffenheit der Steine zu untersuchen.
Das Ergebnis ist überraschend. Das Material ist dem auf der Erde noch ähnlicher, als die Wissenschaftler angenommen hatten. Einiges ist aus Vulkangestein und gleicht den Formationen, die in den Ozeanen der Erde entstehen. Befand sich diese Ebene wirklich einmal unter Wasser? Ein Größenvergleich mit der Erde. Von der West- zur Ostküste Nordamerikas sind es etwa 4000 Kilometer. So lang ist diese Schlucht auf dem Mars, der Mariner Canyon. In früherer Zeit vielleicht einmal mit Schnee bedeckt.
Der rote Planet ist faszinierend. Etwas mehr als halb so groß wie die Erde hat Mars viel mit ihr gemeinsam. Auf dem Mars gibt es eine Atmosphäre, Jahreszeiten und eine Tageslänge von 24,5 Stunden. Die Sonne ist im Schnitt 228 Millionen Kilometer entfernt. Ein Sonnenumlauf, das Marsjahr, dauert 687 Tage.
Auf dem Mars ist es bitterkalt, mit Temperaturen bestenfalls um den Nullpunkt. Wie bei der Erde ist die Achse des Mars geneigt. Durch die Neigung und die elliptische Umlaufbahn entstehen die Jahreszeiten. Am Nordpol wächst die Eisfläche im kurzen, relativ milden nördlichen Winter. Sie schmilzt im langen, relativ kühlen nördlichen Sommer.
Am Südpol nimmt die Eisfläche im Winter erheblich stärker zu. Im Vergleich zum Norden sind die Winter im Süden lang und hart. Der Sommer im Süden aber ist kurz und weniger kühl als im Norden. Einer Theorie zufolge ließen einst Vulkanausbrüche Eis unter der Marsoberfläche schmelzen. Wasser überflutete den Planeten. Eine Atmosphäre aus Kohlendioxid entstand. Die Temperaturen stiegen. Warum bildete sich dann aber kein Leben?
Vielleicht lag es am wechselhaften Klima, eine Folge der schwankenden Marsachse. Der Hauptgrund war aber wahrscheinlich das Erlöschen der Vulkane. Dadurch konnte sich die Atmosphäre nicht weiter aufbauen. Sie entwich ins Weltall. Die Sonde Global Surveyor erfasste den Mars mit großer Genauigkeit. Aufnahmen von Gebieten wurden gemacht, in denen die Anhänger der Ozeantheorie alte Küstenbereiche vermuten. Doch die neuen, hochaufgelösten Aufnahmen zeigen keine Anzeichen für eine Küste.
Die Ozeantheorie ist aber nicht gänzlich widerlegt. Weitere Missionen sind notwendig, um die Strukturen auf der Marsoberfläche noch genauer zu erkunden. Nur so lässt sich klären, ob riesige Wassermengen einst über den roten Planeten flossen. Wenn ja, wo ist dieses Wasser heute? Verbirgt der Mars immer noch große Wasservorkommen unter seiner staubigen, kalten Oberfläche? Wird die neue Sonde Polarlander in den kommenden Monaten das Rätsel lösen können?
Die Marssonde, die ja seit Jahren ständig um den Mars kreist, ist besonders hilfreich. Einmal konnte man aus Fotos, die sie gemacht hat und zur Erde gesandt hatte, einmal den Landeplatz aussuchen. Zum anderen wird sie jetzt umfunktioniert als Relaisstation für die Funksignale von dem Mars-Lander zur Erde. Nun, morgen um 5:30 Uhr, morgen in der Früh, haben die Wissenschaftler nochmal eine Chance, auf ein Signal vom Mars-Lander zu hören. Vielleicht mit Erfolg. Wenn Sie am Universum interessiert sind, morgen übrigens starten wir unsere neue Serie Geheimnisse unseres Universums, morgen um 19:30 Uhr im ZDF. Vielleicht bis dahin guten Abend.
Die Weltraumbehörde NASA hat zurzeit keinen Kontakt mehr zu ihrer Marssonde Polarlander. Die Forschungssonde sollte eigentlich gestern Abend auf dem Mars aufsetzen. Kurz vorher verloren die NASA-Experten das Signal. Einzelheiten von Christoph Lang aus den USA.
Das Kontrollzentrum gab sich Mühe, den Humor nicht zu verlieren. Mars Polarlander ruft zu Hause an. Diese Botschaft an die verschollene Sonde hielten die NASA-Mitarbeiter in die Kameras. Leider vergeblich, wie man sich denken kann. Die bange Frage ist, was genau geschah beim Landeanflug, bei dem keine Funkverbindung zur Sonde bestand. Der Polarlander sollte, so wie hier gezeigt, abbremsen und sanft aufsetzen. Falls er stattdessen abgestürzt ist oder im letzten Moment umfiel, dann wäre die Katastrophe perfekt. Doch von solchen Horrorszenarien geht die NASA noch nicht aus.
We had a plan in place for dealing with it, and so I
Wir
think
haben ein Konzept, wie man mit solchen Problemen umgeht, sagt Missionschef Cook. Und das setzen wir jetzt um. Erst danach beginnen wir, uns Sorgen zu machen.
and then we'll begin to worry more.
Man hofft, dass die Sonde lediglich Schwierigkeiten hat, ihre Antennen auf die Erde auszurichten oder dass sich ihr Computer vorübergehend selbst abschaltete. Solche Probleme wären lösbar. Dennoch sind die Gesichter im Kontrollzentrum erstmal lang. NASA-Chef Goldin, hier in der Mitte, wirkte verständlicherweise alles andere als begeistert. Das bange Warten könnte noch tagelang weitergehen. Richtig kritisch, so sagt die NASA, wird die Lage erst dann, falls die Sonde auch Mitte nächster Woche noch schweigen sollte. Der Verlust des Polarlanders wäre für die NASA ein schwerer Schlag. Immerhin hat sie erst vor 3 Monaten ihren Klimasatelliten am Mars verloren und das aufgrund eines peinlichen Fehlers. Techniker hatten sich beim simplen Umrechnen von Längenmaßen vertan.
Space correspondent Miles O'Brien is standing by in Pasadena, California, home to the Jet Propulsion Laboratory. Miles, what's the latest there?
Well, Jim, 3 strikes, but engineers insist they're not down, neither are they out. They've had 3 opportunities, 3 communication passes in which they should have heard or possibly could have heard from the Mars Polar Lander. In each case, it refused to phone home. They're hoping, best case scenario, that it is in what is called a safe mode, which means it's deliberately put itself to sleep and shut down some key systems. It is programmed, if it is in fact in that safe mode, to turn itself back on in a few hours from now, about 12 hours from now to be exact. That's when engineers will be back at their post at the Flight Control Center here, hoping they see some sort of sign from the Mars Polar Lander. Yesterday, the scene was a tense one. There was some jubilance in advance of this landing, but it quickly faded.
10 seconds after
Tension
that.
was high, but so were spirits as the Mars Polar Lander reached the end of its 450 million-mile journey. Munching peanuts for good luck, a landing day tradition at NASA's Jet Propulsion Lab, they joked when they saw precisely where the 13th U.S. mission to Mars was headed.
I wish very much I could show you the piece of real estate we're headed for, just shown to us by the project scientist. It's, well, pretty bland.
That sounds great. Hold it up to the TV. We're watching it.
But the room became silent very quickly when the Polar Lander did not phone home during its first communication opportunity. Not a huge concern, not even a surprise, given the vagaries of communication across 157 million miles of space.
There's nothing to be seen this time.
A little more than an hour later, they tried again. This time, the dish-like medium-gain antenna programmed to conduct a methodical search for Earth, a cosmic needle in the void. But after 45 minutes, still no joy.
Obviously, we're a little disappointed not to see the signal at 12:39, but we prepared for this, and we're going to go ahead and execute our plan as we described it.
All of it is starkly reminiscent of the scene here 10 weeks ago when the same team lost the lander's sister ship, the Mars Climate Orbiter. The lander was to use the doomed orbiter as its communication relay to Earth, but now will use the Mars Global Surveyor, already in orbit around the red planet. But the polar lander cannot use that communication path until a pair of 6-pound microprobes, which hitched a ride with it, get their chance to phone home.
Now, this is a life-size model of one of those microprobes. It's about the size of a grapefruit. They were supposed to crash land into the surface. No one has heard from them yet either. Now, they will keep the lines open on that global surveyor until tomorrow morning, Sunday morning Eastern time, after which time they'll switch to another antenna on the Mars Polar Lander, this UHF antenna, where they've been using this dish-like one up till now. It will try to communicate with that Mars Global Surveyor. If they don't hear from it then, that's when the concern level will rise dramatically. Miles O'Brien, CNN, Pasadena, California.
Well, for more information on the Mars Polar Lander and links to other websites, click on cnn.com/Mars.
Mars ist das Schicksal der NASA-Sonde Polar Lander noch ungewiss. Bislang konnte kein Funkkontakt hergestellt werden. Die nächste Gelegenheit dafür bietet sich erst in 6 Stunden. Bis dahin können die Wissenschaftler im Kontrollzentrum von Pasadena nichts tun, als abzuwarten. Sie hoffen, dass die Sonde die Landung überstanden hat und nur ihre Antennen noch nicht ausrichten konnte. Das ließe sich von der Erde aus korrigieren.
Despite its silence since an apparent landing on Mars that was on Friday. Their next chance to receive signals from the craft comes about 7 hours from now. CNN's Jim Hill joining us with a little bit more information. He's with the space fans in Pasadena, California, home of NASA's Control Center, where the mission is being tracked. Jim?
Well, Jim, the scientists at the Jet Propulsion Laboratory in Pasadena, California, have been on pins and needles now for 25 hours. 25 hours ago, the Mars Polar Lander was supposed to have set down on the red planet, and within a short time, pointed its microphone toward the Earth and radioed home saying, "Hello, I'm here and I am okay." That, of course, did not happen. There were 3 different opportunities, windows of communication, if you will, that came and went with no signal from the Mars Polar Lander or from 2 probes that were along for the ride with it. Now, in conjunction with all of this tension, we have an organization, the Planetary Society, holding its convention. It's Planet Fest 99, also in Pasadena, California. Now, the Planet Fest is an opportunity for people from children to adults to serious science buffs, really, to look at the planetary and technical exhibits here. Kids can practice phoning Mars in a mock-up display and so forth. Some former astronauts are here for speaking engagements. So this is something that was hoped to go right along with the Mars mission. As a matter of fact, a microphone constructed by the Planetary Society was put onto the polar lander, and they hoped that they would hear from that today. But as people go through the exhibits here, they are watching them rather intently, but also keeping one eye on that Mars mission.
I like the Mars Polar Lander stuff, all about that. I think it was pretty bad that they didn't get the signal, but I'm hopeful that they'll get it tonight or tomorrow.
Hoping for good results on it. But the kids have had a good time learning about the surface of Mars and learning about the environment and seeing what we could do to make Mars habitable for us. So we've been following it on the internet.
Well, it seems like all their former missions have gone so well, but this one didn't.
Now, the scientists at the Jet Propulsion Laboratory are confident that they will eventually get a signal from the Mars Polar Lander. They say there are not only opportunities through the weekend, but also early into next week. So they say there are a lot of things that they can do to try to wake up the lander if it's in fact in a protective sleeping mode, and things that they can do to make its microphone search the skies, essentially, the Martian heavens, and find the Earth and then radio home. So they still have some hope and indeed some optimism. I'm Jim Hill reporting live from Pasadena, California.
Hours. They have not detected any signals from the spacecraft yet, assuring them that it made a safe landing on Mars Friday. But scientists say they are remaining upbeat. They say the lander may have missed its mark or experienced computer problems that can be corrected. Scientists have one more chance to try to communicate with the Mars lander on Saturday. U.S. space scientists are hoping to receive signals from the Mars polar lander, in fact, some 6 hours from now. And there has been a nail-biting silence from the vehicle since its apparent landing on Mars Friday. CNN's Jim Hill joins us now with more from Pasadena, home of NASA's Control Center, and he's with some space fans there. Jim.
That's right. Pasadena, California is host to not only the Jet Propulsion Laboratory and the host of scientists there studying the Mars mission, but I am at an event called the Planet Fest 99. Now, this is at the Convention Center in Pasadena. This is put on by the Planetary Society, which is a group of scientists and lay people who promote science and space exploration. Now, at this Planet Fest 99, it was designed to coincide this year with the polar landing mission. However, because of the lack of a signal, people who are attending the exhibits here, looking at the booths designed, by the way, for youngsters and serious scientists alike, are all wondering if they will finally get to hear a signal from Mars. That is one of the big attractions in Pasadena right now. Among those who are attending the Planet Fest 99 is actor Gary Sinise, who is the star of an upcoming movie called Mission to Mars, and like everyone else, he is very concerned about the polar lander mission.
Since I started working on Mission to Mars, every time there's something in the paper or, you know, on the news or anything about Mars and the polar lander, and I'm automatically drawn to it. My eye goes to it. So I have been following this in the news and the newspaper. And yesterday I was here at Planet Fest watching on the big screen and hoping for the signal to come in. So there's still hope.
One other big attraction here at Planet Fest 99 in Pasadena is the Planetary Society's microphone, which it assembled with some $100,000 in funding. This microphone was placed aboard the polar lander, and the Planetary Society was hoping to hear live the first sounds from Mars and broadcast them live right here at Planet Fest 99. So that organization also rather disappointed right now that the signals have not been received from the polar lander, and also very hopeful that they will eventually be received, and perhaps along with them some live sounds from the Planetary Society's microphone, which hopefully is safe and sound on Mars on the polar lander right now. I'm Jim Hill reporting live from Pasadena, California.
Jim, is there any talk now that we haven't heard from the polar lander about the September 23rd loss of another sibling to the polar lander?
Well, certainly NASA and JPL are both under a lot of pressure because only 10 weeks ago, as you say, there was the loss of a space launch to Mars. That was a rather embarrassing loss. It was a simple mathematical navigation snafu and could easily have been corrected if they had caught it in time. So there was a lot of embarrassment over that. Also, it made it more important for NASA to make this particular mission, the polar lander mission, a success. 2 failures in a row would certainly call into question the way NASA is operating. And by that, I mean NASA is now trying to build spacecraft in a way that it calls cheaper, faster, and better. It's looking for low-budget ways to put spacecraft toward the red planet and accomplish these missions. So that whole idea of cheaper, faster, and better may be called into question itself if this particular mission, the polar lander, ends up being a failure as the previous mission 10 weeks ago.
CNN's Jim Hill.
Game for NASA scientists who are holding out hope for any sign of life on the Mars polar lander. Well, that probe hasn't been heard from since Friday when it began its descent toward Mars. NASA's next window of opportunity to hear from the spacecraft begins about 5 hours from now at 11:15 Eastern Time. CNN's John Zarella is at the Jet Propulsion Lab in Pasadena, California with the latest. John, what's the latest word?
Well, Catherine, you know, it may not be the end of the game, but NASA engineers are certainly moving into the second half, that's for sure. Right now, Mission Control is quiet. The engineering team is preparing for a meeting later this afternoon Pacific time to decide exactly what they will do this evening when the opportunity opens to hear from the Mars polar lander. They don't know what they might hear if they hear from it. It might just be a signal that says, I'm here and I'm awake. and then they will have to decide whether they want to send commands to the polar lander to begin sending down data that it may have stored in its memory from the descent yesterday. Of course, that would be the big hope, that they would hear from it and they would begin to get some initial data from the spacecraft. But those decisions will be several hours away, as you indicated. What they will do, though, when that window opens, is they will be listening for a signal from this antenna, a medium gain antenna on the spacecraft, which will communicate directly back to Earth. Now, if they do not hear a signal this afternoon, well, this evening, Eastern time, from the spacecraft, what they will do then is wait until tomorrow morning. And tomorrow morning is another opportunity where they might be able to hear a signal from another antenna on the spacecraft. And using that antenna, they will be going through a relay satellite, the Mars Global Surveyor, which is already in orbit around the planet. So they still have some options available to them for the next couple of days, but clearly with each failed opportunity to contact the spacecraft, it becomes less and less evident that that will happen. But right now, they are still confident. They say that what happened 2.5 years ago when the Pathfinder landed on Mars was just so good, so perfect, that this is the way it's supposed to be, and they hope that this evening will be the charm. This is John Zarrella reporting live from Pasadena. Catherine?
John, have the scientists offered any scenarios of what may be going on up there, or what may have happened?
What they think might have happened is that if there were some kind of an anomaly during the descent phase of the spacecraft's mission down to the planet, that it would have gone into a safe mode, literally protecting itself. And because of the descent phase, the battery power may have been sapped so much that it had to recharge its batteries. And now they hope that it will wake up when they make contact with it this evening. Catherine?
At least they're not giving up hope then, right, John? Thanks.
No, they're not.
CNN plans to bring you live coverage of the NASA briefing on the Mars polar lander. It's scheduled for 1:30 a.m. Eastern Time. That's 6:30 GMT. And ahead of...
Please phone home. NASA scientists tracking the Mars polar lander are hoping for a signal from the spacecraft shortly. One of its pre-programmed communication windows will open in about 15 minutes. CNN's John Zarrella is standing by in Pasadena, California with the latest. John.
Marina, actually, they've pushed up that timetable just a little bit now. We're actually only moments away from the opening of that window, that opportunity for the men and women, the controllers, the engineers here at the Jet Propulsion Laboratory to hopefully get a signal back from the Mars polar lander. They are gathering now in mission control, awaiting this opportunity. They believe that it will be within the first half hour or so of this opportunity to hear from polar lander that they have their best chance to get a signal back from the spacecraft. Now, they have a pretty good idea where the spacecraft landed. Late last night, they put together a 3D animation that shows the projected path of where polar lander came down near the south pole of Mars, and that's based on the final telemetry readings they got from the spacecraft before it entered the Martian atmosphere and went into that blackout phase where they no longer heard from it on the way down to the ground. Now, joining us is Lori Leshin. She has been with us throughout the last couple of days, and she is, of course, a member of the polar lander team. And Lori, what will we expect tonight to happen, and then what might we hear from polar lander if it calls home?
Well, starting in about 10 minutes, the window opens for us to hear back from the lander, and we'll hear back from it tonight if it went into a safing mode, if it had some kind of error on board and shut down to take care of itself. It wasn't even scheduled to wake up if that happened until now. And so it should wake up and use its medium gain antenna to call home and say, I'm here, tell me what to do, and here's a bunch of housekeeping data, as we call it, which will be just some engineering data, temperatures of the electronics, what the memory's doing, things like that, the state of the lander.
Won't get any pictures then tonight?
That's right. We won't get pictures tonight. Even if we do hear from the lander, we won't get pictures down. Probably the soonest that would be tomorrow evening.
Okay, what happens if you don't hear from the lander tonight? What's the next step?
The next step is to switch from listening for the medium gain antenna to this link, which will actually try and use the Mars Global Surveyor Orbiter to phone home at about 10:50 a.m. local time, Pacific time, tomorrow morning.
And if you hear from the lander tonight, no need then to use that antenna tomorrow. and you would go into tomorrow evening's phase where then you would begin to get more data and perhaps pictures, images.
That's right. If we hear from it tonight and we think it's in a pretty good state, we're going to start our mission tomorrow night.
And a lot of the engineers and scientists that I've been speaking with have said, look, you know, this isn't over yet by any stretch of the imagination, that the more we look at what's happening here, the more this makes sense that this might have happened if there was any glitch within the last hour all the way down to the surface.
Yeah, that's absolutely right. The mood up in Mission Control, I just came from there, it's pretty optimistic that there's still a lot of very realistic scenarios that we could be in where we wouldn't have even expected to hear from the lander until now.
And quite a few scenarios that they can still run through, correct?
That's right, even if we don't hear tonight.
Lori, thanks so much for taking some time here with us this evening. And of course, Lori and I will be here throughout the course of the next hour or so as NASA listens for a downlink from the spacecraft. And there are, of course, many, many people over at UCLA, which is the Science Operations Center, who are tremendously interested. A lot of Lori's colleagues there, tremendously interested in getting started in all of their science work. And that is where my colleague Jim Hill is. And Jim, I bet they're just chomping at the bit there, aren't they?
Oh, absolutely, John. You know, a lot is riding on the Mars Polar Lander. The hopes, the dreams, and the hard science of some 130 scientists, many of whom are here at UCLA now to watch as roughly 10 minutes from now that window of opportunity opens and the much awaited and hoped for signal may in fact come through. I want to talk to one of them right now. This is Ashwin Basavada. He is a professor who helped pick the landing spot on Mars. This is not a basketball. This is, in fact, a globe of Mars. Can you orient us, show us the spot that you chose and why you're confident that the spacecraft is there and is safe?
Sure. This is a globe of Mars with the North Pole. You can see the ice cap at the top, South Pole at the bottom. And as you can tell, we're landing pretty far south. This yellow spot marks the landing site. We chose this site because of its unique geographical location on Mars and what it can reveal about the weather and climate of Mars. Also, we chose it based on some very excellent data from orbit. We have topographic data and we have pictures of this area that suggest that it's a safe site, not only where we aimed, but in a good area around that.
Now, based on what they are calling the telemetry of, or the trajectory of entry,
right.
You're confident it is in fact there, and this is, in fact, is this the best case scenario spot, or is it somewhat iffy?
Well, we have some predicted locations where it hit the top of the atmosphere. We lose the signal at that point, but then we can predict in a range of locations where it might have ended up on the surface. And from our best data, our best computer models of that, it appears it landed in an area that should be safe for it.
Now, if you were a betting man, what kind of odds would you give? We talked with Peter Smith from the University of Arizona earlier today, and he said it's about a 50-50 chance that there's going to be a signal heard during the window of opportunity coming up.
Right.
What odds do you give this?
Well, that's a tough question to answer. I mean, I think the team is really hoping that this is going to be it tonight, or maybe tomorrow morning. I'm not one to place odds, but I'm really hopeful we're going to hear something. I think the teams are doing just an excellent job at JPL and Lockheed Martin of making sure we hear that signal tonight.
Okay, well, let's hope this is, in fact, the sweet spot. Let's hope that, that the craft is sitting there safe and sound and anxious as everyone here is to phone home, as they say. I'm Jim Hill reporting live from Los Angeles.
Jim, but how much are they talking about perhaps more the negative side of things are not as optimistic, and perhaps the same fate could have happened to the lander that happened to the orbiter, which was in fact lost September 23rd by the same group of people?
Well, I think we're talking about apples and oranges in that case. You have to recall that the spacecraft that was lost 10 weeks ago was lost to a well-known cause. They are certain it was a mix-up over metric and imperial measurement units, and that was a definitive cause. Not only that, after that mishap occurred, from what I understand, the scientists and the engineers on this particular project, the Polar Lander project, went through everything. Double and triple checking to make sure that the same kind of mistake had not been made on this particular spacecraft. They're confident that it was not made. They're also confident through that double checking process that all of the systems were as they should be. So I think they're confident they've eliminated that particular likelihood in this particular case, and that as we heard from other scientists, the trajectory was just as they wanted it as it approached the Martian atmosphere and went into this blackout mode, turning its turning its face and transmitter away from Earth to enter that atmosphere. So certainly there's been a lot of speculation in the last 24 to 30 hours about what could be wrong, but we're going to know an awful lot in the next hour or so, and starting in only about 5 or 10 minutes. So it's kind of the hour of truth, I guess you could say.
CNN's Jim Hill reporting from Pasadena, California.
And welcome to you. I'm Michael Holmes at the CNN Center in Atlanta. NASA scientists say they are not giving up hope on the Mars polar lander, and they will once again try to make contact on Sunday. The latest opportunity to reach the craft on Saturday was answered again with silence. CNN's John Zarella looks at a second disappointing day for the Mars mission team.
Want to let you know because I know you're looking at.
They waited, they listened, they watched a computer monitor hoping to see a spike in the oscillating line on the screen. A spike that would have meant Polar Lander was calling home. But nothing happened. Polar Lander remained silent.
4-3's looking for the one-way and the two-way frequency, with 4-5 looking for the two-way, and we still don't see anything.
At a news conference following the fourth failed attempt to contact the vehicle, the mission's top engineers maintained their resolve.
It's certainly trying on people's patience, but we're going to hang in there and follow the plan we laid out. There are other elements in that plan that we haven't checked yet.
There are, engineers say, at least several more days of contingency plans to work. The team will send up various sets of commands to Polar Lander, hoping something they tell it will do the trick. There are 2 opportunities Sunday for the spacecraft to respond. But as each attempt fails, hope fades.
As time goes by, you know, I'm not going to tell you otherwise. We're less confident. But at this point, we still have a lot of things we can try, and we're going to keep doing that.
High-tech imaging and information from the spacecraft before it entered Mars' atmosphere indicate the terrain the lander set down in should have been easy for the vehicle to handle. Reasons why it may not be transmitting range from a computer glitch to a catastrophe. The engineers have, in a sense, become like doctors trying to revive a dying patient. They are trying everything they can, and they are refusing to give up hope. John Zarella, CNN, Pasadena, California.
Auch mehr als 30 Stunden nach der geplanten Landung auf dem roten Planeten haben die Techniker kein Signal der Sonde empfangen. Doch noch hat die US-Weltraumbehörde die Hoffnung nicht aufgegeben. Den ganzen Tag will sie weiter versuchen, Kontakt aufzunehmen. Ein Fehlschlag der 165 Millionen $ teuren Mission wäre ein Desaster für die NASA.
Die Experten der NASA im Kontrollzentrum in Pasadena geben die Hoffnung nicht auf. Polar Lander, bitte melde dich, die Message ins All. Doch auch die zweite Nacht nach der vermeintlichen Landung tat sie das nicht, hat man auf der Erde kein Signal erhalten. Es herrscht Rätselraten, warum sich die Sonde noch immer nicht gemeldet hat. Ist sie vielleicht kaputt oder ist sie überhaupt nicht auf dem Mars gelandet? Die Hoffnung konzentriert sich auf die Möglichkeit, dass die Polar Lander nach dem Aufsetzen ihre Systeme selbst als Vorsichtsmaßnahme abgeschaltet hat, um eventuelle technische Probleme zu korrigieren. Möglicherweise vielleicht auch hat sich eine Antenne noch nicht richtig ausgerichtet oder ein Computer musste neu gestartet werden. Projektmanagerin Sarah Gavitt macht ihrem Team Mut. Selbst wenn der nächste Versuch der Kontaktaufnahme scheitert, so kündigt sie an, werde man es noch mindestens 2 oder 3 Tage lang versuchen. Die NASA steht unter Druck, nachdem erst vor wenigen Wochen eine Marssonde durch einen peinlichen Rechenfehler verloren gegangen war. Sollte auch diese Mission scheitern, wäre dies ein schwerer Schlag für die amerikanische Raumfahrt.
Einen Tag nach der geplanten Landung auf dem Mars hat die NASA immer noch keinen Funkkontakt zur Sonde Polar Lander. Auch die beiden Mini-Roboter, die sich eigenständig melden sollten, sandten noch keine Signale zur Erde. Bei den Wissenschaftlern im Kontrollzentrum Pasadena wächst nun die Sorge, dass die Sonde bei der Landung zerstört worden sein könnte. Sie versuchen aber weiter, die Antennen von Polar Lander auf die Erde auszurichten.
I'm Jim Clancy at the CNN Center in Atlanta, and this is an overview of the stories making headlines around the world right now. NASA scientists planning to make another attempt Sunday to contact the Mars polar lander. Mission Control saying it's looking at several options, including using another antenna to make contact with the spacecraft. A 2-hour window of opportunity passed Saturday night without a signal being received from the polar lander. Well, NASA's next opportunity to try to make contact with its Mars polar lander now less than 3 hours away. Scientists say that if they fail once again to communicate with the spacecraft during Sunday's 10-minute window of opportunity, they're going to try what they call more desperate measures. Scientists listening for a signal from the craft on Saturday heard only silence. NASA officials say they will try using a UHF antenna to make the next contact. Meantime, they are trying to figure out what went wrong.
One fault we've postulated is that maybe our batteries in our telecommunication system are too cold. If the probes would have warmed up due to the daily temperature cycles, they probably would have done it by now. It's been a full 24 hours since we first tried to communicate with the probes. There still is some chance that the probes could warm up if it's in that situation in the next 24 hours, so we're going to continue to look for that. Now, it is possible also that maybe we were cold enough that our batteries would freeze. Our batteries would freeze at about minus 85 degrees C, and in that case, our computer would go down, our clock would stop, and as the system warmed up again, the computer would power up and resume counting, and what that means, the effect of that is that our auto-transmit mode would be delayed. So it's possible our auto-transmit period could be delayed anywhere from 1 to 2 days off its original schedule from 29 and 32 hours.
NASA scientists still stressing the positive, saying there is still cause for hope that they'll be able to contact the polar lander. Well, the polar lander was sent to Mars originally to search for ice, which scientists hoped might contain evidence that life has existed or could exist on the red planet. But as CNN's Miles O'Brien reports, the search for life on Mars really begins right here on Earth.
When you come to a place like this and look around, you think it's dead. There's nothing alive.
Death Valley, so named for good reason. Or is it?
In fact, there's a lot of life there if you know where to look. Nice, beautiful green. Isn't it? Just like in a textbook, you know.
Scratch beneath the surface and you will find this unlikely place brimming with life. You just have to know where to look.
Oh, wow.
And no one knows better than Chris McKay, part scientist, part explorer, part microbial gumshoe. His job, looking for life in all the wrong places.
What I've done for longer than I like to think about is gone to places on Earth that are extremely cold and or extremely dry, and just try to understand what's going on there.
That would be enough for a lot of scientists, but Chris McKay works for NASA and is driven to the ends of the Earth to learn more about life in a place even he can't get to, Mars. It'd be nice to have a car on Mars, wouldn't it? You know?
Yeah, and roads that we can follow that take us right to the site.
Ready for a new site.
See this thick layer of green there? The algae are growing under the rock.
Few stones go unturned in his quest to understand where life may be hiding here in places that are most like Mars. And maybe, just maybe, that may help unlock the mystery of life on the red planet.
And this could actually be an important lesson on Mars. Just a small amount of dust could hide to our eye or from a satellite what's really there. The more we learn about life on the edge, the more we learn about life in these limited environments, the smarter we'll be in a kind of indirect way that's hard to predict. So I know it's useful, but I can't say precisely how it's going to be useful. Learning about these algae and where they live and how they live has got to be the key to finding them on Mars.
If you want to be a successful detective in this racket, you need to search for clues on a cold, faint trail. Researchers say one thing is certain. If you want to find some answers, you need to follow the water.
What's limiting here on Earth and on other planets seems to be liquid water. So following the water is a good strategy for finding life.
Which is precisely what the Mars Polar Lander was designed to do. No one suggests it will settle the big question, but if it completes its mission, it will add an important piece to the puzzle. But there is more than one way to solve this riddle.
In here we have a number of samples of 3 different Mars meteorites.
In an air-conditioned lab 1,000 miles away, another NASA scientist named McKay is trying to answer the same question in a very different way. David McKay, no relation to Chris, leads a team that studies meteorites from Mars.
We're not here to establish, as in a courtroom, beyond the shadow of doubt that life existed on Mars. But we're here today to open the door just a little bit.
In August of 1996, amid much fanfare, McKay's team revealed what they say are fossils in a Mars meteorite found in the so-called Allen Hills of Antarctica. They claim it is strong circumstantial evidence that life once existed on Mars. It was and is controversial, so the team is busy looking for new ways to prove their point.
We're trying to understand the fingerprints of life. How do you know that this rock that I go out and pick up somewhere, say in the desert, how do you know that this rock ever had life with it, either inside of it or before it formed as a rock? How do we know that there was life here? Well, what we do, we look for biomarkers, which are the fingerprints of life.
It may be organic chemicals or magnetized bacteria or some other trace element. They are convinced somewhere in these rocks there is a smoking gun that will prove what their intuition tells them.
I'm very optimistic that we will find life wherever we find liquid water in our solar system or elsewhere. I think for some reason life is incredibly hardy, and it seems to be hard to get started, but once it's started, boy, is it hard to kill off.
It's hard to really know what you're looking for and to be able to get there. It's a challenge here on Earth. It's even harder for a robot. Imagine.
Life is tenacious, and so are the scientists who are trying to understand just how ubiquitous it may be.
When we look at the history of the Earth, life appeared very quickly on the Earth. Now, it could be a fluke. It could be that we won the lottery on our first day when we bought the first ticket. But more likely it's not. More likely life is a natural thing that just pops up wherever there's water and energy and carbon and all the other things.
Right?
Put it all back.
Yep.
Like
just the way it was. Bury it back up.
Exactly.
Okay, see you guys later.
California, where the waiting game continues for signals from NASA's missing Mars polar lander. The spacecraft hasn't been heard from since it approached the red planet on Friday. CNN space correspondent Miles O'Brien is at NASA's Jet Propulsion Laboratory in Pasadena with the latest. Miles?
Wolf, the flight controllers here at JPL have tried 4 separate times to raise the Mars polar lander, a $165 million spacecraft, and so far it has not answered. In less than 2 hours' time, perhaps the most important test. Thus far, they have been trying to reach it on this antenna. It looks a little bit like a satellite dish. It communicates directly with Earth. So far, they've been unable to raise it on that particular antenna. At about 1:50 p.m. Eastern Time, they'll switch to another communication system. This is a UHF antenna, which is designed to reach an orbiting satellite around Mars, the Mars Global Surveyor, which in turn will relay that data back to Earth. If that particular antenna and that particular transmission path does not work, the concern here at the Jet Propulsion Laboratory will rise. Although it's not over yet, there'll be another attempt to try to raise it on this direct antenna around the midnight hour Eastern Time. So there's a few options left, but quite frankly, Wolf, the concern here is growing by the minute.
So what you're saying, in about 2 hours, what will we specifically know, and what will that tell us?
Well, what it'll tell us if, for example, they aren't able to raise the Mars polar lander on that separate communications link, what it will tell us is that whatever is wrong with the Mars polar lander, it is something that is probably reflective of the entire lander, not just specific to this one communication device, not this one antenna. It could be in what is called a safe mode, which is a protective mode, and not unlike what your computer does when it crashes and it needs to be rebooted. Or it could be something, if you go all the way down the list of scenarios, where something catastrophic happened, either broke up as it came in or crash landed, or it landed askew and is unable to point toward Earth. So there's a lot of scenarios. If they don't hear from it on this antenna, though, they will start to worry here.
All right, we'll be watching in 2 hours to get the good or bad news. Thanks for joining us, Miles O'Brien in Pasadena.
Sonde Polar Lander ist nach wie vor verschollen. Experten der US-Weltraumbehörde NASA haben inzwischen zum 4. Mal ohne Erfolg versucht, Kontakt zur Sonde aufzunehmen. Polar Lander sollte eigentlich schon am Freitagabend auf dem Marsboden aufsetzen. Kurz vorher hatten die Wissenschaftler aber bereits ihr Signal verloren. Die NASA kann zur Stunde noch nicht sagen, ob die fast 400 Millionen Mark teure Mission gescheitert ist.
Taking a closer look at the situation with the Mars Polar Lander, a 10-minute window of opportunity is going to give NASA scientists just one more chance to contact the Mars Polar Lander. Then they say they may resort to what they are terming more drastic measures. Well, that window is opening less than an hour from now. CNN Miles O'Brien joins us with the latest. Miles.
Jim, this will be the 5th opportunity for flight controllers here at Pasadena's Jet Propulsion Lab to check in and see if the Mars Polar Lander will answer back. Let's take a look at a live picture from the flight control room, which is just a few buildings away from where I sit right now. Still a little bit quiet in there as the flight controllers prepare for this 10-minute communication pass. Now, they won't know exactly at that moment if they've had some success, because there's a series of relays that it has to go through. The UHF antenna on board the Mars Polar Lander, which sits right about here, will send a signal up to the Mars Global Surveyor, the orbiting satellite, which has been up there for some time. It will in turn relay information to a site in San Diego owned by an outfit called Malin Space Science Systems. They're the folks that operate that orbiting satellite, and then in turn that information will be sent here. So there's a bit of a lag time before the flight controllers here will know one way or another if the Mars Polar Lander is able to communicate with that UHF antenna. Up to this point, all the communication has been on this dish-like antenna called the medium gain antenna. It is a direct-to-Earth link and has to be pointed very precisely within a 5-degree band to the Earth. Anything beyond 15 degrees and you're too far off in order for it to hit the antennas on Earth. If for some reason that antenna was unable to point properly, or if its amplifier had died, perhaps this UHF antenna will make that clear if it is able to make a connection with the satellite and ultimately with the Earth. Now, what that does is once that particular antenna goes into action, it seizes the phone line, if you will, from these small microprobes, which had hitchhiked their way some 450 million miles with the Mars Polar Lander, deliberately crash-landed into the surface of Mars about 35 miles away from the Polar Lander, and were to send scientific information back to that satellite and ultimately back to Earth. So far, they have not been heard from, and I would say at this juncture, the outlook for them is not very good as to whether they are actually healthy in transmitting science. Here to shed some light on that and some other issues is Lori Lesham with Arizona State University, part of the science team. Lori, first of all, at what point will these small grapefruit-sized microprobes, and by the way, this is life-size, at what point will they be declared lost mission?
Well, I couldn't speak for their mission engineers there, but within the next day or two, if we don't hear anything, it's pretty unlikely we're going to from the microprobes at this point. Whereas with the lander, we do have a much longer kind of a faulting scenario where we can go through and try different things for much longer, because we could be gathering solar power to charge our batteries on the lander.
Of course, the limiting factor here is you have batteries and no solar power in which to recharge it. Very cold environment. They're not going to last very long.
Exactly.
Now, tell us, just walk us through what we're going to see in the next 50 minutes on this 10-minute comm pass with this UHF antenna, which thus far hasn't been tried on the Mars Polar Lander. What is likely to happen? What, if things go well, will they see on their screens?
Well, what will be sent back if we do manage to communicate in this way is the housekeeping data that we've talked about previously, which is engineering data basically about the health and state of the lander. What tilt is it at? What temperature are the electronics at? How's the memory doing? Things like that.
All right, now, and if it should fail, about 12 hours later, they'll go back to that medium gain antenna and try another pass with it. As they do this, they are basically checking off the boxes, testing various potential failure modes, correct?
Yes, that's exactly right. We've gone from testing out sort of single point problems, failures, to testing slightly more complicated scenarios. And as you say, they're going through quite methodically a list of possibilities and testing each one.
Has anything been ruled out just yet?
Well, what we ruled out last night is that the lander was in safe mode, perfectly pointed towards Earth. If that had been the case, the lander should have woken up last night and called home, and we should have heard it.
All right, so that's the one thing that's off the table. We know at this point, if it's in safe mode, it's not pointed properly. So if it's safe mode, will it be able to communicate with that UHF antenna, or will that require another test to make sure that that is the case?
If it's in safe mode, we will not hear from the UHF antenna. The UHF antenna pass will only work if the lander has been carrying out some pre-programmed sequences on board that will tell it to phone Mars Global Surveyor at this certain time. We can command the UHF pass from a safe mode and we'll try that at a later time within a day or two.
So this UHF call that is being made is like giving your son or daughter a calling card and telling them to phone at a certain time if there's an emergency, and that's what's going to happen. If there's a problem and it's shut down completely, we're not going to hear from it. But what kind of conclusions can we draw if during that 10-minute period the UHF signal doesn't come in?
Well, it probably tells us that we're in a safe mode. Assuming the lander is safe on the surface, it probably tells us that we're in a safe mode and might be having some medium gain antenna problems. So we're eliminating things slowly but surely. We're eliminating different possibilities and trying out others.
All right, Lori Leshin with Arizona State University helping us understand what is a very complicated task for engineers trying to troubleshoot something which is 157 million miles away. Stay with CNN. We'll, of course, bring you the latest word on this next opportunity, the 5th opportunity to check in with the Mars Polar Lander. The moment we hear anything, one way or another, we'll bring it to you. Jim?
Okay, Miles, we're keeping our fingers crossed here. Well,
Hello, I'm Miles O'Brien, reporting live from the Jet Propulsion Laboratory, Pasadena, California. We're now 46 hours and 35 minutes since the Mars Polar Lander should have landed on the surface of the red planet, but we are not certain one way or another if it ever made it. It has been 4 times now that flight controllers here have attempted to talk to the Mars Polar Lander, a $165 million space probe, part of an ongoing effort to answer some basic questions about Mars. But in 4 attempts, they have had no contact whatsoever. The 5th attempt is just beginning now, and a new communication path is being used. We won't know exactly if it's been successful for a little bit of time. Let's talk to Lori Leshin with Arizona State University, part of the science team, and ask her what is going on right now inside that control room. Lori.
Well, what they're doing is waiting for a signal from Malin Space Science Systems in San Diego, where the data will go directly, because it's being relayed through the Mars Global Surveyor camera, which is run out of Malin Space Science Systems. So at this point, presumably Malin is getting some data down and having a look at it to see what's there.
And just to clarify, Malin Space Science Systems, the people who built the camera on board that Mars Global Surveyor, and thus have some control over the relay, which would be this radio relay between the UHF antenna, thus far unused on the Mars Polar Lander, and ultimately Earth, one would hope.
That's right. That's literally our communication satellite, the Mars Global Surveyor, and through the camera system on that.
All right, now this differs from what has been tried to date on the 4 previous attempts. On the 4 previous attempts, they were using this dish-like satellite antenna, which was attempting a direct path to Earth. It's a very narrow beam that it has to focus in order to get a communication link with Earth. Thus far, that hasn't worked out.
That's right, that's right. And unlike the medium gain antenna here, the UHF is only talking up to an orbiter just above its head, and it also has a broader range that it can speak over. So it ought to be a really strong signal to the surveyor, I'm told, and so we ought to really hear it if it's going.
This is a critical moment, isn't it?
It is, because it's really testing probably our last single fault kind of scenario, where if only one thing isn't working on the lander, we could have expected to not hear from it. That is, if there's a problem with this medium gain antenna, we shouldn't have expected to hear anything yet. If that's the case, we should hear from the link through the orbiter.
Now, as we mentioned, Lori Leshin is part of the team at UCLA. She happens to be with Arizona State University. If you look at NASA television right now, you'll see some of the key people from that UCLA team. Right in the middle of your screen is Dr. David Page, the man in charge of the scientific package on top of the so-called science deck of the Mars Polar Lander. To his right, Karen McBride, his operations manager. As a matter of fact, there are quite a few people back at UCLA who are on pins and needles right now, hanging on tenterhooks, hoping that this communication pass is the one that will do the trick. Let's go to Jim Hell, who is there now and has the temperature of the room. Jim?
Well, Miles, a lot rides on the Global Surveyor right now, or the lander, rather. One way to think about it is this device that hopefully is sitting on the Martian surface is roughly, what, 2.5 by 3 feet? If you can imagine some 130 scientists all standing on top of that, piled high, that is the amount of scientific power, really, that this lander represents. 130 scientists have experiments that they hope to conclude at the end of a 90-day period, starting as soon as that critical signal is established between the Mars lander and the Earth. Now, in the room where the scientists are waiting now, of course, on pins and needles, they're hoping for this final attempt, really, of the weekend to try to get in touch with this particular lander. Miles?
All right, CNN's Jim Hill at UCLA. That communication window opened about 5 minutes ago. We're right in the middle of it. As we say, we won't get any real-time data for you. It'll take a little bit of time before the information is fed up to the satellite and then ultimately fed to Earth. If all goes well, we should know maybe 10, 15, 20 minutes from now. Stay tuned to CNN. This fifth and critical communication pass underway right now. We'll have results one way or another for you very shortly. We now return to CNN Earth Matters.
Attempt to contact the elusive Mars polar lander. You're looking at live pictures from the Jet Propulsion Laboratory in the U.S. state of California. Project managers have been unable to receive any signals from the spacecraft since its landing Friday near the South Pole of Mars. Those are our top stories here on CNN.
Did not provide any sort of signal from the Mars polar lander. This information just streaming into the flight control area here at the Jet Propulsion Lab just a few moments ago. Joining me, who listened to it with a much more learned ear than I did, is Lori Leshin with Arizona State University on the science team. A lot of jargon coming down that way to my ear, but what you heard was essentially what?
Well, what I heard was that, that we received a signal from Mars Global Surveyor, and what that signal said was that it hadn't heard from the lander. All it got down was its own data, and we think that that relay was good, but at this point it has not heard from the UHF antenna on the lander, as far as I could tell from listening to the commentary and mission control.
So in listening to Mike Malin of Malin Space Science Systems, La Jolla, California, the operator of the relay of this satellite, in essence, what he was telling the flight team here at in Pasadena was that everything was good with the satellite. The relay was working fine.
That's right. He reported on the health and status of the relay, and everything seemed to be normal.
All right. And the fact that the UHF antenna located here on top of our model here of the Mars polar lander, that UHF antenna, which is a secondary communication system separate from this direct-to-Earth system in every way, different transmitter, different antenna, different links entirely. The fact that that doesn't work, what does that leave controllers with as far as options?
Well, right now we're going to pursue two different possibilities, which are both sort of double fault modes. Either the lander is in safe mode and the medium gain antenna is working but pointed the wrong way, in which case tonight we'll listen and have that medium gain antenna scan when the lander would wake up from safe mode. The other possibility is it's in safe mode, and therefore the UHF would not have called us, and they need to try, and if there was something wrong with the medium gain antenna and it's in safe mode, we wouldn't have heard from the UHF. So it gets a little bit confusing here, obviously.
And as they say, there are multiple branches on this so-called fault tree. I mean, we can show it to you here, folks. It's a very complicated series of scenarios that the engineers are running through. If this, then this. If this, then that. Most of it is prescribed, but toward the end of this evening, they run out of pre-prescribed fault tree items, and they're sort of going to have to step back and start over, in a sense.
Yeah, they're going to have to think about the right order to attempt different scenarios next, to attempt to listen for different scenarios next after probably tomorrow night, I would say.
How much does this ratchet up the concern level for you and the team?
Well, I've been telling people I wouldn't get nervous until after this pass, so I mean, obviously it does increase our concern significantly, but there is still the possibility that the lander's in safe mode and the medium gain antenna isn't working, in which case we'll have to command that UHF antenna to come on. So that's another reasonable possibility.
Lori Leshin, hanging on to any shred of optimism that there may be. Let's turn it over to UCLA, where the primary scientific team is. That's where Lori Leshin does most of her work. That's where I find my colleague, Jim Hill, who is there, getting a sense of the reaction there. Jim?
Well, Miles, of course, the scientists have been waiting all weekend, ever since Friday, really, for a signal along with the engineers. The engineers, of course, where you are the people who've been flying or operating the spacecraft, and they're responsible for making sure it gets to Mars and comes down in a position that is safe and sound. And then they hand it over to the scientists here who are gathered at UCLA, some 130 scientists. And in the meantime, the scientists can do little more than wait. They are not the experts in how to fly the spacecraft, how to land the spacecraft and so forth, or how to contact the spacecraft. They are waiting because what they need...
We have been listening here as the news has come in. No contact with the Mars polar lander. A disappointment there to the scientists at the Jet Propulsion Laboratory, but they will keep trying. We are going to return our California project managers talking about their attempts to contact the Mars Polar Lander.
Start up our next attempt to communicate with the lander. As you all saw on NASA TV, we were hoping to get a signal through the Mars relay on the Mars Global Surveyor spacecraft. It looks like that did not occur. And so we were able to check off that box on our contingency plan. And I thought I would sort of give you a little briefing this morning about where we're planning to go from here. So if I can get the first slide up. This, we've been talking a lot about, you know, how we're working through our plan, and this particular chart, which I know is very difficult to read, is in fact a summary of at least the first elements of that contingency plan. And basically what you see in front of you is up at the top is a little box that says no first downlink. And what you see as each of those branches are the various contingency paths and the actions that we would take as a result of those contingencies. And so you can see by the gray shading that those are the branches that we've more or less eliminated from from possibility at this point. The ones on the left were the ones that we principally did on Sol 0, which was Friday. The ones on the right were the things that we checked as a result of this pass this morning. The thing in the middle, the path in the middle, is the spacecraft in safe mode path or possibility. We've checked about the top half of that, but we're now going to proceed with the lower set. So if I can have the next chart, which is a blow-up of that lower piece, you guys actually might have a chance of reading it. It's the next set of steps. Now, what's represented on this chart is really what I would call our big cards that we can play, the things that are the most likely to cause us to be able to get a communications. I think there are clearly things beyond that, beyond what's shown here, which we will continue to attempt to do. But these are the things that are really the most likely. And when we get done with those, I think we're really at the point of diminishing returns as far as the likelihood of getting a communications. But let me go through what these three remaining things are. Up at the top, you can see the MGA downlink on Sol 1, which we, as you know, tried last night, December 4th at about 8:30. Didn't see anything there. The next action that we're going to take will be tonight, where we do again another MGA downlink on Sol 2 in this case, but we'll do the raster scan that we attempted to do in other modes earlier, and so that would allow us to identify or to check out this situation where you had both the gyro compassing problem and the spacecraft in safe mode. So that's a pretty reasonably likely scenario, and so we're going to go ahead and check that out tonight. Beyond that, there's two additional ones that we'd like to verify from this safe mode path, which is, again, all of these things are in the safe mode path. The first is a very large pointing problem, larger than what the raster scan that we're going to try to do tonight will handle. And so right now we're planning, preliminary at least, planning to do a larger scan tomorrow night, which would be Sol 3. And so you see that's the left-hand branch, December 6th at around 11 p.m., so essentially tomorrow night. Then beyond that, we want to check out a path which is a DTE hardware problem plus safe mode. And just to give you an example, for example, if you had a failure to deploy the medium gain, where the gimbal itself had a problem, that would actually, when you attempted to move the medium gain, it would put the spacecraft, you wouldn't be able to move it. That in itself would put the spacecraft into safe mode, and then again, you wouldn't be able to move it, and so you would never have gotten any of the communications. So that's a single fault case, so to speak. So we really want to check that one out as quickly as we can. And so we're going to do a commanded UHF pass tomorrow night from within safe mode. And so we'll check that out on hopefully December 7th, about 12:20 a.m. So those are as I said, are the big cards, the things that the cards we still have to play. We have a large set of additional ones that we'll continue to work on beyond that, but I think that frankly, the likelihood of success of those is relatively small. So just to summarize that, let me show you again the chart that I showed you last night, the Sol 2 and 3 communications windows. The one that we did this morning is at the top. The one we're going to do tonight is next up. That's the MGA raster scan if in safe mode. Then we do a larger raster scan tomorrow, and as well as the downlink in safe mode. So with that, as I sort of have been saying all along, we continue to work through our plan. That gives us confidence that until we get through that, we haven't exhausted all the possibilities. Clearly the team is getting more frustrated, certainly, and more tense about all of this, but I think because we have a well thought out plan, it allows us to focus and to begin to continue to check off those boxes. So with that, I'll let Sam fill in some details and give you his thoughts.
Well, I don't have a whole lot extra to add. I think it's, as Rich indicated, we have a course of action for the next couple of days that's very clear. We reach a point roughly coming into Tuesday where our existing contingency plan has been completed in terms of all the paths, and we just now have some efforts going to look a little bit further down at what additional commanding and all we might try to work our way around and exercise responses that would get around very specific hardware faults that might have occurred on board the vehicle. Honestly, we can't say a whole lot more about what those might be until we see some more of what happens in our next couple of attempts here, again, following the same type of process of elimination of possibilities that Rich showed. So stand by. I think we'll be describing in more detail where we might go following the bottom end of Rich's chart within the next day or two. I'll now turn to Sarah for an update on the DS2 microprobe status.
Okay, good afternoon. My briefing will be rather short because I don't have a whole lot new to tell you since last night. Last night at about 11 o'clock p.m., we had hoped to receive data from our first auto-transmit pass for which there's a good link margin. And again, auto-transmit mode is the mode that the probes go into if they haven't heard from the Mars Global Surveyor spacecraft for a certain amount of period after impact. What they will do is they will transmit autonomously for 1 minute out of every 5 minutes until they either hear from the Mars Global Surveyor spacecraft or until the batteries expire. That data was successfully collected last night, but the team hasn't received it yet. There are actually two ways of getting data down to Earth. One is to send it down to Earth in the real-time data stream. The other is to put the data on the recorder to be played back to Earth later. And the data was actually put on the recorder last night, and so it will not be played back and sent to Earth until this evening. During the Mars Global Surveyor playback period last night, our team was actually able to get a full night's sleep, the first since we've impacted, so I think everybody's feeling much better today. I know that I am. And the reason why is because when the Mars Global Surveyor is playing back data, it can't send data back real time, so we really didn't have any new data to look at last night. Today is a very busy day for us. We will have new data to look at most of today and this evening. That will include what is now our first opportunity to look at data since the probes should have operated in auto-transmit mode with a good link margin as well. To be honest with you, the next 24 hours for the probes is really telling. I think if we haven't heard from them in the next 24 hours, we will have exhausted most of our options, and we will continue to look for the probes once a day all the way out through Sol 9. But to be honest with you, the chances of hearing from them will be greatly decreased by tomorrow morning.
Okay, just wanted to mention that the chart that was shown of the opportunities will be available shortly in the newsroom here at JPL, and it will also be placed online at our news website at www.jpl.nasa.gov/marsnews. And the project also has a website at marslander.jpl.nasa.gov. With that, we'll go to media Q&A here. Let's start with Kathy and Bill down here.
Kathy Sawyer, The Washington Post. Could you sum up what you now think is the most likely state the craft is in? I know you have this complicated, horrible, confusing list of options, but what's your best guess? What main things have you eliminated, and can you give a rundown of based on these assumptions and looking out through December 7, in which states can you fully recover? From which can you fully recover? And in which states will you be partially limited, assuming you do get a signal from any of these attempts?
Okay, yeah, we can answer that question. In general, the cases that we've more or less eliminated up to this point are the ones where the spacecraft is running the sequence that we loaded on it prior to landing. That there are numerous cases within that, as far as the medium gain is not pointed correctly. The medium gain, when I say it has to be pointed correctly, it has to be pointed within about 5 degrees to get data. So it does take a fair amount of accuracy in pointing. So there's that problem. A problem with the actual hardware itself. For example, if you'd lost a solid-state power amplifier, which is the thing that powers that direct-to-Earth downlink, those are the cases that we more or less have eliminated already. In addition, we've eliminated the simple, so to speak, simple case of where the spacecraft was just in safe mode and everything else was okay. Although there's still the possibility that it was in safe mode and had a pointing problem with the medium gain, which I think a lot of people would say is a reasonably likely situation. That's the one we'll check tonight. When I say that we've eliminated the medium gain pointing problems, I say that in the sense that we've eliminated them because we've done these searches. Now, those searches are certainly covering a large fraction of the sky, but not, I mean, we could do a bigger search even than that. And so, we will be trying to do that over the next few days. And then finally, there's the one that I mentioned where you had for example, you were in safe mode and you had a hardware problem. Get the gimbal as an example that turns the medium gain antenna. The solid-state power amplifier is another one. And so those combinations are things that we'll check out by using the UHF system tomorrow night on Sol 3 at night. In the cases that remain to be looked at, you still have a viable communications path, but otherwise they wouldn't work. And so the mission can be recovered if any of those turn out to be a success. I mean, if there's a large pointing error with the medium gain, we can fix that. Even if we have a hardware failure in the direct to Earth, we still have the UHF as a backup, and so those are all recoverable problems. Just to clarify, I know there's a fair amount of questions about how the antennas and all what we're talking about. Just on the model over there, the medium gain, obviously you can tell, is the dish antenna. The UHF system is the helical, helix-shaped antenna there, which it's kind of short and with 4 pillars that come up and a little spiral set of wires that are within it. It's a little hard to point out from here, but it actually is can see over a very wide range, and so that's what we use to communicate with the orbiter. It's sort of an omnidirectional antenna, and it can both transmit and receive. Now that it was designed primarily for use with Mars Climate Orbiter, which is why it can transmit and receive. The Mars Global Surveyor spacecraft and the Mars relay that's on MGS cannot transmit. I mean, it cannot send. You cannot send commands to MGS and then have them go down to the lander. It can only listen. MGS can only listen. The low gain, the X-band low gain, the thing that we've been sending commands over primarily, is actually over on the other side. You can't see it from here, and it's a little patch antenna that's omnidirectional, but is facing towards the sort of the north, which is where the Earth should be. And so it's actually what we've been using to command. But we do have 2 omnidirectional antennas. One is UHF, which we use to talk to MGS, and the other one is X-band, which we use to talk to the Earth, or actually listen from the Earth. So I know people have had questions about it.
Okay, Bill?
Bill Harwood, CBS. There's not an answer to this question, I'll say in advance before I ask it, but I'm just
that's easy.
Yeah, isn't it? I'm just looking for some insight on worst-case failure scenarios. I know from the landing site stuff that Sarah was telling us last night, I've gotten lots of email from folks who speculate, as people will, about the cruise stage not separating, and that could account for all 3 being gone at the same time. Does the landing site for the Deep Space 2 probes, the nature of that, realizing there's no one answer to this, but does that maybe, you can think that you really could lose them at the landing site and still have the separate problem? I'm just wondering what your all's thoughts are on that.
We think the likelihood of failed crew state separation is low. That's a simple event. There are redundant initiators and the pyro devices that make that happen. We obviously can't rule it out, but that's not one that we would put very high on the likelihood list as being responsible for not hearing from all three vehicles. You know, Sarah, I guess you'd have to address the impact site question.
Well, I think certainly the probes could have been greatly affected by the landing site. And with respect to the lander, I don't know if I can completely speak for it other than saying that we really have never been to this region before. So I personally would think that the landing site could be a factor in all three.
Yeah, absolutely. I mean, landing on Mars is very hard. And it's the part where you're landing where things get really hard. and you know, it doesn't take much to have a problem. And even on places that, I mean, you've seen the pictures of the Pathfinder landing site. That's, you know, there's lots of places out in those images that could cause problems. And we haven't even seen, you know, we've never been to this region. So it's easily a possibility that the landing site could be the cause.
Okay, we'll take a couple over here and then we'll move over here.
Alan Paul from NBC News. I'd like to ask about the Stanford dish that we were told about a few days ago that could listen to the microprobes transmitting from the surface, and whether or not any data or any signal had been received from the Stanford dish that was capable of hearing that.
The data has been recorded. As of the press conference last night, they had not had time to review the data, and to be honest with you, I have not contacted them yet this morning, so I don't have any new status for you on that.
It just seems as an observation that that would be a little higher priority than I mean, because that would tell you whether things were alive up there, right?
Well, actually, they're doing a lot of things for us, and the bigger priority is to verify that the Mars relay is working and properly sending the beacon to the probe. So that was their first priority. The reason why looking at the direct signal from the probes, the second priority, is because we think that that was a long shot to begin with. We have never had a lot of confidence that we could detect that signal, and that's because the probe's transmitters only put out a ½ watt. Yeah, that's enough to light a Christmas tree light bulb. So that's like trying to talk with someone with a cell phone on Mars. It's extremely hard to do. We decided to go ahead and try it. We had nothing to lose, but the likelihood that we can detect it is probably pretty slim to begin with.
Scientists with lowered expectations. Obviously, there are a lot of disappointment could be heard in the voices. We want to take you now live. Our Jim Hill standing by at the University of California, Los Angeles. Jim, what are we to make of what the scientists have to say here and the hopes that they have?
Well, Jim, as you saw, there was an increasingly somber mood day by day as this unwinds with no signal from the Mars polar lander reaching Earth. We heard Richard Cook, the project manager, say that there is frustration and tension with each step that's attempted but fails. The most recent step, of course, was the attempted broadcast with what they call the UHF antenna, which is a wide-ranging signal intended to reach the orbiting Mars Global Surveyor and relay that signal onto Earth. I have a 1/10 square model of the spacecraft here, and this right here, this device is the UHF antenna, which had about a 10-minute window earlier today to transmit a wide-ranging signal, hopefully going up to the orbiting Surveyor satellite and onto the Earth. That did not happen, so that is the 5th failure of a signal to come through in 5 tries. Earlier, the tries involved this particular device right here, which is the medium gain antenna. It looks very much like a satellite dish you might have on your house. Now, 4 separate tries to have this essentially aim itself toward Earth and send a signal, those all failed. What they're going to try to do tonight is open another window with this medium gain antenna. Try it one more time. And there's also the chance that they can program this or command this to do what they call a raster search. And in that case, the dish moves around looking for Earth. It has pre-programmed movements in an attempt to find the Earth. And at that point, once it does acquire a signal or a line with the Earth, it's very much like a rifle. It will line itself up and shoot a very concentrated signal that should reach the Earth, I believe, in about 14 minutes or so of travel time. But those are the latest things we're going to try. Now, in terms of the two devices that were dropped off from the lander, which were to fall through the atmosphere and embed themselves in the Martian soil and begin sending a signal. These were the Deep 2 space probes. We heard from Sarah Gavitt, the woman in charge of that particular project. She has not heard any signal from those two probes either. And she said as of about, in the next 24 hours, they will have exhausted about all of their possibilities there. So that is also looking fairly grim. So at this point, the experts are going to try again tonight, but as they progress into the week, going down a chart of possible problems and possible solutions, it becomes ever more complicated for them to try this and ever more remote that they will in fact get a signal. Jim?
All right, CNN's Jim Hill there at UCLA. Thanks for keeping watch for us and putting into perspective some of what we heard in that press briefing. We're going to take a break here on World News. When we come back, we'll be talking about some events much closer to our own planet. Stay with us.
Gathering around their computer screens here at Pasadena, California's NASA's Jet Propulsion Laboratory. Once again, grim faces, as when the word came back from the spacecraft and from the satellite, which was going to be relaying the information, that there was, in fact, no contact from the Mars polar lander, now about 49 hours since it was to have landed on the surface of the red planet. They were using a separate antenna, as we said, a UHF antenna, which was radiating in a very different way. We can take a look at it here on the model, if you like. Up until this point, they were using this dish-like device, which has to be pointed very, very precisely at Earth, within a 5-degree tunnel, if you will. They moved over to this antenna, UHF, which radiates not nearly as precisely, and which reaches a satellite. The satellite, in turn, relays that information to Earth. That's the Mars Global Surveyor, the satellite specifically. This time around, no word from the Mars Polar Lander, suggesting that in this case, there is something that isn't normal about this spacecraft. Now, that seems like a trite thing to say, almost obvious, but the fact remains, up until that point, it was possible that the spacecraft was in a safe mode, which was built into its programming. That safe mode designed to protect it when something goes wrong, sort of like when a computer needs to be rebooted. Let's turn now to one of the executives at NASA who's been watching over this program since its origin. Steve Brody is the program executive for the Mars Polar Lander. Steve, tough day, obviously. That fifth one, there was a lot of hope that that fifth pass would be a good pass. Just give us a sense of the mood in that room, first of all.
Well, it is tough because you go through an emotional roller coaster. We're so hopeful, and we still have a lot of good hope for the opportunities that lie ahead. And then when the signal doesn't come, you have to check off that box, and of course there's a little bit of a letdown, but then you get your adrenaline pumping for the next opportunity.
That's the nature of the business, I know, that engineers find problems and attack them, and that's what's going on. But as you say, there are only a few cards left in the deck. Are they strong cards, in your opinion? And explain what they are.
Definitely, they are strong cards. As you mentioned here on the model, we tried this UHF antenna, which, if the spacecraft had been nominal and everything else okay, would have given us a signal. It didn't, so that makes us think once again that there is a safe mode, a nominal procedure that the spacecraft goes into, and we're going to try again with the pointing, scan around the sky a little bit more with it, and we have another opportunity to go back to the UHF. So they are very strong cards for us.
So running through the scenarios here, we initially, prior to trying this UHF antenna, it was thought that perhaps this dish just wasn't pointing right for whatever reason. That becomes less of a possibility now because of the fact that the UHF antenna, this other antenna, wasn't working either?
That's right. In other words, the UHF, if everything else was just fine on the spacecraft, we would have expected to hear through the UHF. So that is pointing back to something with the spacecraft which could be related to the medium gain, the dish on the spacecraft. There are a number of other things that are not quite right that we'll go through tonight, and then again tomorrow night to check out before we feel we've really thrown our aces into the kitty to see how we do.
So it's the next 24 to 36 hours, very important, clearly then. Let me ask you this, a lot on the line here for NASA. This is the latest in what is a underlying philosophy that we've come to know as faster, better, cheaper, meaning more frequent, less expensive missions. The critique has been, in advance of this mission and subsequent to the loss of the Mars Climate Orbiter, the sister ship of this one, that the pendulum has swung too far, that too much has been cut. Is there a growing feeling that maybe this needs to be reevaluated?
There's a feeling, I'd say, in some circles. I don't think it's as well-founded in that the missions that we are flying now, we're flying more regular missions. They can get off the pad within a few years. More opportunities. We've had some great successes, Mars Pathfinder, Lunar Prospector, our Deep Space One mission, and they're all into this new mode. So we have to also be prepared for losing a spacecraft every once in a while, even though we do everything humanly possible to avoid those errors.
That's a tough position to be in, though, having to explain that, because what you're doing is taking higher risks, and implicit in that risk is the problems that you run into with Congress and the American people with support.
That's certainly true. I guess we wouldn't be in this business if we didn't feel passionately about what we're doing, and that the American people feel that to take bold steps and to go out on the very frontiers is part of our psyche and what we're all about.
All right, Steve Brody, who is the program executive for the Mars Polar Lander and who says he has a few aces up his sleeve. We'll be playing those aces over the next couple of days. Nevertheless, a very difficult day for the flight controllers, for the team in general here at the Jet Propulsion Lab, as this fifth and one of the most critical so far of the communication passes once again offers nothing in the way of a signal from the $165 million space probe. Miles O'Brien, CNN, reporting live from Pasadena, California.
Okay, Miles, thanks to you and your entire team there for keeping us up to date. Another tough day. There's always tomorrow.
Scientists in the U.S. are now planning a new effort to make contact with the Mars Polar Lander. Only silence was detected on Sunday during their fifth chance to get a sign that the craft had touched down safely on Friday. CNN's John Zarella joins us now from Pasadena, California with the latest. John, what's the update there?
Well, Glenn, certainly a cloud of disappointment descending here over the mission team, the engineers, and the program managers. This was hoped to be a very good opportunity to hear from the spacecraft. It was one of the primary aces that they had in their pocket, the engineering team, to throw at the problem. They did not hear from the spacecraft. They will attempt to hear again later this evening. The control room is, of course, empty now. Many of the members of the engineering team are in a meeting to figure their next courses of action. It was, of course, packed earlier today when they were awaiting word through what is a UHF antenna, a different antenna than they had been trying to communicate with the spacecraft. But no success there either. Steve Brody is joining us, and he is with the Polar Lander team. And Steve, as we have been talking, this does not mean it's over. You still have some shots.
We still have some very good shots. Tonight and tomorrow night, I'd say we're going to give it our best shots that we have remaining, and that's to reestablish or establish communication directly with the Earth.
What will you do? What antenna will you use again this evening?
Well, this evening, if we look at the model, the medium gain antenna, which is the dish that's here, that's the one that has to be very accurately pointed to the Earth. We'll go back and try that again, assuming that commands that we sent yesterday allowed that to get calibrated and pointed properly, which we felt was one scenario that it wasn't pointed properly. Tomorrow night, assuming we don't have success with this medium gain, we'll go back to the UHF antenna here on the model, which really looks at the full sky. And we have tried that already, but that was assuming everything else on the spacecraft was fine. Now we go through a path where we assume there are some things that are broken and use that antenna to really blast the sky and see what we can do with communicating.
So it is really a very methodical process of elimination that you go through in these steps to talk with the vehicle. The reality, though, what happens in the next couple of days? Is there a drop-dead day, so to speak, where you start to say, well, it's probably lost?
Well, I'd say by noontime on Tuesday or shortly after early hours here on Tuesday morning, if we have not, through these processes, established communication, we would say that we've played our best cards. Now, there are some things that we'll be doing following that. I'd say the likelihood of establishing communication goes quite down after that period.
Of course, if indeed the vehicle is lost, and Climate Orbiter was lost a couple of months ago, then the two Mars 98 vehicles headed to Mars lost. A serious blow to the Mars exploration program?
I would say in the large course of time, it's a blow, but it's something that we'll recover from. We're launching spacecraft more frequently now. We have a program of trying to get out to the planets and get out there regularly, so that any serious blow that is serious at the moment, and certainly for the team it would be quite a blow, we will recover from and go on and do bold things later on.
Steve Brody, thanks very much again for taking time to be with us here. He had just come out of a management meeting where they're discussing the options for later this evening here in Pasadena, California, and again through the next couple of days. Still a chance to hear from the spacecraft, make contact with it. Certainly the engineers are doing everything humanly possible to contact a vehicle that is 165 million miles away. This is John Zarella reporting live from the Jet Propulsion Laboratory in Pasadena, California. Glenn?
All right, thank you, John. We'll check back with you.
In Pasadena ist gar nichts passiert. Da sitzen Dutzende von Raumfahrtexperten im NASA-Bodenzentrum und warten auf ein Zeichen. Aber auch heute Abend hat die Mars-Sonde Polar Lander nicht reagiert. Keinerlei Funksignale vom roten Planeten. Kann sein, dass damit schon wieder ein Mars-Projekt der NASA gescheitert ist. Christoph Lüttgert.
Heute Abend im NASA-Kontrollzentrum Pasadena. Der 5. Versuch, Funkkontakt zum Mars-Polarländer zu bekommen. Anspannung und auch schon Erschöpfung bei den Wissenschaftlern. Am Freitag war, wie auf dieser Computeranimation, der Mars-Polarländer zielgenau auf den roten Planeten zugerast. Seitdem hörten und sahen die NASA-Wissenschaftler nichts mehr von der Sonde, obwohl sie diverse Möglichkeiten ausprobierten. Kurz vor 20 Uhr deutscher Zeit der jüngste Versuch. Vielleicht waren ja nur die Sender des Polarländers zu schwach für den direkten Funkkontakt zur Erde. Deshalb sollte der Satellit Surveyor, der schon länger um den Mars kreist, als Verstärker genutzt werden. Aber auch das klappte nicht. Vor 3 Stunden im NASA-Zentrum Pasadena. Frage an den Kontrollraum. Habt ihr irgendwas Neues gehört? Nein, wieder nichts. Also ein neuer Fehlschlag. Kurz darauf Pressekonferenz. Alles lief prima bis kurz vor der Landung. Je mehr Möglichkeiten wir jetzt durchprobieren ohne Erfolg, umso mehr schwindet unsere Zuversicht, dass die Sonde tatsächlich gut im Zielgebiet gelandet ist. Hier, am Südpol des Mars, sollte der 165 Millionen Dollar teure Polarländer nach Berechnungen der Wissenschaftler weich aufsetzen. Jetzt aber droht der NASA der 2. Fehlschlag innerhalb weniger Monate. Ich glaube, dann muss die NASA ihr Konzept überprüfen. Haben sie genug Leute? Haben sie genug Geld? Wurden bei der Koordination fundamentale Fehler gemacht? Da müssen sie sehr genau hinsehen. Ungewiss auch, wo die beiden Minisonden sind, die der Mars-Polarländer abstieß. Nach ihrem Aufschlag sollten sie fußballgroße Projektile in den Marsboden drücken, um die Beschaffenheit zu ergründen. Die Batterien für Funksignale, die bisher nicht aufgefangen werden konnten, sind bald leer.
NASA will try again in a few hours to contact the Mars Polar Lander. After a failed attempt this afternoon, scientists say they are running out of options to save the multi-million-dollar mission. CNN's John Zarella is following the mission from the Jet Propulsion Laboratory in Pasadena, California. John.
Marina, well, the old saying, if at first you don't succeed, try again, and that's what the engineering team here at the Jet Propulsion Laboratory intends to do. There have now been 5 failed attempts to contact the Polar Lander spacecraft that they believe is sitting down at the South Pole of Mars. A sixth attempt will take place later this evening here in Pasadena, California. What they did today was to use an antenna, this antenna, which is a UHF antenna. It was the first time they tried to contact the vehicle using that antenna. That antenna would send the signal to an orbiting spacecraft over Mars, a spacecraft that is orbiting Mars now, and use that spacecraft as a relay back to Earth. But they had no luck. They had been initially trying with this medium gain antenna, which is a direct link back to Earth, on the first 4 attempts, and there was no luck. Again this evening, they will attempt to use this medium gain antenna. If that does not work, tomorrow another opportunity to use both of these. But of course, with each passing opportunity, it becomes less and less likely that Polar Lander is in a position to communicate with the mission engineers and scientists. But at the same time, they are not giving up.
We continue to work through our plan. That gives us confidence that until we get through that, we haven't exhausted all the possibilities. Clearly, the team is getting more frustrated, certainly, and more tense about all of this. But I think because we have a well-thought-out plan, it allows us to focus and to begin to continue to check off those boxes.
They're doing a continual, very, very methodical, one step at a time, working through all of the potential ways that they can communicate with the spacecraft. The team was gathered earlier in a meeting, the control room area pretty much empty now as they meet to formulate plans for the next couple of days. There is no, quote, drop-dead day at this point, but it looks as if tonight's possibility to contact the spacecraft, tomorrow's couple of options, and then into Tuesday. After that, all of the best possible scenarios for reaching the Polar Lander spacecraft would have been exhausted, and at that point, they might be willing to come out and say, we've done our best, and it just does not look good. But at this point, they are still hoping against hope that with a couple of options left to go, that they will be able to contact the Polar Lander. This is John Zarella reporting live from the Jet Propulsion Laboratory in Pasadena, California.
US-Weltraumbehörde NASA Kontakt zu der verschollenen Marssonde Polar Lander herzustellen, ist heute Morgen gescheitert. Experten im Kontrollzentrum Pasadena im Bundesstaat Kalifornien hatten gestern erklärt, es werde immer unwahrscheinlicher, dass die rund 165 Millionen Dollar teure Sonde genutzt werden könne. Die Bemühungen sollen aber fortgesetzt werden. Planmäßig hätte die Mars Polar Lander seit Freitag von dem roten Planeten Informationen senden sollen. Ende September war bereits eine andere Marssonde verschollen.
7 minutes past 8 in London. The US space agency NASA is losing hope this morning of ever making contact with its Mars Polar Lander. The unmanned spacecraft was in good condition as it began its landing on Friday, but mission controllers have heard nothing from it since then. Several communication windows have passed without a signal, the latest one about an hour ago, and the project manager says there's only one realistic chance left.
You can see from watching NASA TV, we didn't get any signal during the raster scan. Not entirely unexpected, but we wanted to check that one off, that box off, so we went ahead and did that. As I said this morning, we're pretty much reaching the point where we've used up our final silver bullets. Tomorrow night will be pretty much the last, I think, high probability attempt that we have.
If the Polar Lander is declared lost, it will be the second major NASA mission to fail in the last 4 months. The lander's sister craft, the Mars Climate Orbiter, was lost in September after a mix-up over metric and imperial measurements.
Long shot. That is how NASA scientists are describing their chances of successfully contacting the missing Mars Polar Lander 252 million kilometers from Earth. Overnight, mission controllers tried and failed for a 6th time to coax a signal from the silent space probe. Scientists have not had any contact with the lander since last Friday's scheduled touchdown at the Martian South Pole.
Operating thus far under the assumption that there's something wrong with the radio system on the lander that would try to communicate directly with Earth. That's why we were hopeful when we tried the orbiter that we might be able to contact it. That didn't work last night, but we'll try again on Tuesday morning.
The $165 million polar lander was designed to look for water on the red planet.
Plan to try again Tuesday to communicate with the Mars polar lander, but they say that will be their last good chance to establish contact. CNN's John Zarella joins us from Pasadena, California. John?
Bernie, there had been so much faith, so much hope that the engineering genius of the NASA engineers here at the Jet Propulsion Laboratory would be able to find a way to communicate with the Mars polar lander. But on 6 attempts, no luck. They are down really now to the last attempt they have. Late this evening, early tomorrow morning, they will begin to use this UHF antenna, which is a broadband scan of the sky, to try and get a signal back from the polar lander on Mars's surface. They will try for about 1 hour. After that, engineers say this is their last best silver bullet. If this doesn't work, there will be very little chance that Mars polar lander will ever be heard from again. This is John Zarella reporting live from the Jet Propulsion Laboratory in Pasadena, California. Bernie?
On what went wrong, John?
Well, Bernie, what we know now is that NASA's administrator, Dan Golden, is in fact going to launch a complete and thorough investigation into the second loss of a Mars-bound spacecraft in just under 3 months. Of course, the Mars Climate Orbiter was lost in September. Polar lander now believed lost perhaps on the surface of Mars. No one may ever really know where it is. And Golden says he will also take steps to look into whether they are actually doing business properly here at the Jet Propulsion Laboratory, and whether his philosophy, faster, better, cheaper, is working, or whether it's been sliced too much to the bone. Lots of questions to be answered now. A blue ribbon commission will be impaneled to look into and investigate what is wrong with NASA's Mars program. Bernie?
Is there anything more they can do, John?
There's really nothing more they can do. The real frustration for these people here is that they don't know what went wrong. If they knew, then perhaps they could redesign, but they don't know, so they don't know what to fix. In the case of the Climate Orbiter, they knew that it was human error that caused it to burn up in the atmosphere. In this case, they may never know what caused it, but what clearly is going to be the result is, because of this, is that the 2001 mission, the 2003 mission, and the 2005 mission, all very ambitious landing missions to Mars, are in jeopardy. They may not fly. The only one that appears to be safe, Bernie, is the 2001 orbiter, which is not linked, obviously, to a landing on Mars. So NASA's Mars program is going to get a top-to-bottom review and some very thorough scrutiny in the weeks and months to come. Bernie?
John Zarella, thank you.
Sowas ist in der Geschichte der amerikanischen Raumfahrt noch nie vorgekommen, dass 2 Mars-Missionen nacheinander scheiterten.
Am 23. September verglühte die Mars-Sonde Climate Orbiter, weil NASA-Wissenschaftler den Anflug falsch berechnet hatten. Jetzt, beim Polarländer, schien alles vom Start an perfekt zu funktionieren. Was dann kurz vor oder nach der Landung auf dem Mars schief lief, weiß derzeit niemand. Jedenfalls scheint die neue NASA-Strategie besser, schneller, billiger nicht aufgegangen zu sein. Wir nehmen die Kurven zu scharf. Wir streben zu ehrgeizige Ziele mit unzureichenden Mitteln an.
Vielleicht haben wir es mit besser, schneller, billiger übertrieben und zu viel gewollt.
Es wurde bei der NASA Personal abgebaut, um die Kosten zu senken. Und von denen, die übrig blieben, verlangt man zu viel. Die Montage des Mars Polarländer vor gut einem Jahr im Kennedy Space Center, Florida. Jetzt will man anhand von Fotos, die bei der Produktion gemacht wurden, nach möglichen Fehlern suchen.
Geändert wurde die Produktion, um sie billiger zu machen. Das ist wohl das Erste, auf das wir bei der Frage sehen müssen, warum die beiden jüngsten Missionen fehlschlugen.
Der amerikanische Kongress will sich demnächst mit den NASA-Misserfolgen beschäftigen. Für dieses Jahr hat er fast 14 Milliarden $ für die Raumfahrt bewilligt. Ich denke, nur 1 Milliarde mehr, also ein Plus von nicht mal 10%, würde ein besseres Programm geben, mehr Testmöglichkeiten, damit Fehler frühzeitig entdeckt werden können. Der Satellit Surveyor, ein Erfolgsprojekt der NASA. Er umkreist den Mars seit 1997. Jetzt soll er den verschollenen Polarländer suchen. Wahrscheinlich aber, so befürchtet die NASA, kann die Kamera des Satelliten so kleine Objekte gar nicht finden.
welcome. I'm Rick Lockridge, and Kellen is on assignment. NASA's high hopes for the Mars Polar Lander mission were crushed last week. Everything seemed fine as the spacecraft approached Mars on December 3rd, and then silence. All attempts to contact it failed. And as John Zarella reports, on Tuesday, scientists admitted defeat.
They waited, they listened, and for the 7th time, NASA engineers heard the sounds of silence from Mars.
I'm sorry to report that all we have is HKTM at this point. It seemed to have been a nominal no-contact MR pass.
Copy that, Mark. Thanks for that. Thanks for hanging in there with us.
Stunned silence. Tuesday morning was their last best chance to hear from the Polar Lander.
Basically, we're at the point where I think we can safely say our expectations for the success of the mission are remote at this point.
Disappointment was felt equally by the Deep Space Two team. Their microprobes that were supposed to separate from the spacecraft and fall independently to the surface of Mars never reported in either. An entire mission lost, $165 million. And what's worse, no one will likely ever know what went wrong. Despite this setback and the unknowns surrounding it, engineers say they will still learn from it.
We're going to have a document this thick, just chock full of lessons learned of how we do these kinds of missions, how we build them, how we test them, how we validate that what we build will work.
The failure of Polar Lander and the loss in September of its sister ship, the Mars Climate Orbiter, may lead to a major review of NASA's Mars program. But the space agency's top officials say Mars exploration will go on. There are robotic missions scheduled every 26 months for the next decade. Those missions are even more technologically challenging than this one. Success won't be easy to come by, and Mars has already shown it doesn't forgive mistakes. John Zarella, CNN, Pasadena, California.
Mars Polar Lander was supposed to be an example of NASA's recent push for missions that are cheaper, faster, better. But some analysts say trying for all three at the same time may not be realistic. Miles O'Brien has more.
At NASA's Jet Propulsion Laboratory, they proudly keep score of some cosmic grand slams. Missions like Voyager, Galileo, and Ulysses. Big birds with plump budgets. But those days are long gone, and space exploration has scaled down and back to the future.
Back to, if you remember, Sputnik and the first Explorer missions were spacecraft that were less than 100 pounds. And we're going back into that type of spacecraft, but we're going back now with a great deal more complexity.
But with a flinty eye on the bottom line, this year's crop of Mars missions cost about $320 million, a tenth of the cost of the Viking spacecraft that successfully landed on the Red Planet in 1976.
I mean, we're pushing the limit, here to figure how far we go, and we have to find the right balance, on what's the most optimum way of assuring success.
But even many at NASA believe they are pushing too hard, and the agency's recent bout with failure is more than just hard luck. They say it is cost-cutting run amok.
I didn't realize how fast and cheap it was going to get.
Peter Smith heads the team that designed and built cameras for the Pathfinder, the Polar Lander, and the next round of Mars missions. He says NASA drives too hard a bargain.
I'd love to have a zoom lens or add some extra capabilities, for gosh sake, and not allowed to do it. Instead, cheaper is the byword. I think we've had enough of cheaper. Let's go for a little more of the better.
NASA readily admits these missions are riskier than the old way of doing business. But one think tank, the Aerospace Corporation, says small science satellites fail at 10 times the rate of traditional spacecraft. Could that much failure put faster, better, cheaper on the line?
One aspect of the new program is we've got that opportunity. All the eggs are not in one basket. You have a chance to continue the program, even with failures.
Some of this is the nature of this risky business. You have to take the bad with the good. But when the dust settles on this embarrassing episode, many analysts believe NASA will be forced to admit the pendulum has swung too far. Miles O'Brien, CNN, Pasadena, California.
Wenn irgendwas bei der NASA passiert, dann wissen Sie es oder zumindest haben Sie es initiiert, oder?
Naja, ich bin jetzt schon seit fast 40 Jahren dabei, so weiß ich schon, was dort gespielt wird. Und gebe mir Mühe, auch weiterhin auf dem Laufenden zu bleiben.
Ja, dann halten Sie uns mal auf dem Laufenden. Da gibt es so eine Raumsonde, die sollte Richtung Mars fliegen.
Ja, ich wusste, dass Sie das bringen.
Ja, meine Theorie, die kommt Ihnen bestimmt entgegen. Also da sind bestimmt ein paar Marsmenschen, die sind ein bisschen cleverer und haben gesagt, das ist ein schönes Stück für den Antiquitätensalon, oder? Und haben das einkassiert.
Nein, das haben wir absichtlich gemacht, damit wir mehr Geld kriegen für die Marsforschung.
So schlau gedacht.
Nein,
aber
wir haben leider 2 Marssonden hintereinander verloren. Die eine durch einen dummen Rechenfehler oder Übertragungsfehler aus dem Englischen ins metrische Marssystem, was nicht beachtet worden war.
Ich hörte davon.
Und die zweite, der Polar Lander, ist verschwunden, ohne dass wir im Augenblick wissen, was eigentlich vorgefallen ist. Wir suchen noch danach, aber wir haben so ungefähr die Suche aufgegeben und haben gerade eine dritte Marssonde, die den Mars umkreist, kommandiert, die mögliche Landestelle mit einer präzisen Kamera zu fotografieren. Vielleicht sehen wir den Polarlander da stehen, vielleicht sehen wir auch nur ein großes Loch im Boden.
Das ist ja auch schön. Aber ich meine, Sie sind ganz sicher, mit meiner Theorie können Sie nicht leben. Es gibt kein Leben auf dem Mars.
Doch, das wollen wir ja suchen. Ich glaube nicht, dass kleine grüne Männlein dort sind, die dem Polarlander schnell seine Schüsselantenne weggenommen haben. Aber Mikroorganismen dürfte es unter Umständen geben an den wärmeren, feuchteren Stellen. Und an sich ist das Mars-Programm ja, zielt ja darauf hinab, die Suche nach Leben, entweder in der Vergangenheit oder sogar heute noch.
Nun haben wir mit unserem Leben genug zu tun. Wie wichtig ist das für die Menschheit? Warum sagen Sie, wir müssen unbedingt da raus? Nicht nur zum Mond, sondern weiter.
Ich sage gar nicht, wir müssen unbedingt da raus. Ich sage einfach, wir tun es. Wenn man zurückschaut in die Vergangenheit, bis ins Altertum, waren die Sterne unsere fernen Leitziele. Der Mensch hat eine Sternensehnsucht entwickelt, daraus entstand Astrologie, Astronomie, die Raumfahrt. Wir sind auf dem Wege, da kann man noch so viel dran herumdeuteln, man kann es oft mit Logik nicht verstehen. Aber wenn man zurückschaut, was für Schwierigkeiten Menschen überkommen sind, Rückschläge, Opfer gebracht, es geht immer weiter. Und Menschen in der Zukunft werden immer weiter gehen. Es wird niemals in meinen Augen der Punkt kommen, wo Menschen einen Strich ziehen und sagen, so bis hierher und nicht weiter. Dann wären es nicht mehr Menschen unserer Art, die Grenzüberschreitungen brauchen zu ihrer Bewusstseinserweiterung.
Hat mich noch nicht so ganz überzeugt. Ich meine, da gibt es ja auch andere Bereiche, in denen man das tun könnte. Und Sie haben immer gesagt, die Raumfahrt, das ist das Wichtige für uns. Mal andersrum gefragt, was ist denn so wichtig gewesen, dass wir zum Beispiel schon mal einen Fuß auf dem Mond hatten? Was ist so wichtig, dass wir jetzt die Marssonde wiederfinden? Was haben wir davon?
Es ist ein kulturelles Programm, das wir tun. Es ist nicht eine Technik. Man darf Raumfahrt nicht mit Gentechnik oder Atomtechnik oder so weiter gleichsetzen, sondern es ist ein kulturelles Unternehmen, in das der Mensch sich hier nun eingelassen hat, schon seit sehr langer Zeit, weil der Mensch instinktiv spürt, dass er nicht in einem geschlossenen System auf die Dauer bleiben kann. Und viele Leute sehen die Erde immer noch heute als ein geschlossenes System und reagieren entsprechend irrational in ihren täglichen Plänen und Vorhaben. Wir wollen zeigen, dass die Erde kein geschlossenes System ist, dass wir eine 4. Domäne erschließen. Land, Wasser, Luft waren die ersten 3. Da gab es auch Schwierigkeiten, bis die ersten Leute übers Wasser schipperten oder die ersten Leute in die Luft vorstießen. Und nun haben wir Menschen, die das All als 4. Domäne erschließen. Nur weil da keine Luft ist, bedeutet nicht, dass man einfach aufhört hinzufliegen. Der Mensch braucht eine Erweiterung seiner Existenzsphäre. Er muss seinen Horizont erweitern, um sein Bewusstsein zu verändern. Und nur dadurch hat er eine Chance, dass er eines Tages ein besserer Mensch wird. Menschen fühlen das instinktiv. Menschen wollen nicht in einem geschlossenen System leben. Auch Tiere können das nicht. Nicht so sehr, weil sie vielleicht verhungern, sondern weil sie psychologisch darunter leiden. Sie werden krank. Der Mensch hat das immer schon instinktiv gefühlt, deswegen hat er neue Grenzen sich erschaffen und hat sie dann überschritten.
Also es ist nicht die Teflonpfanne, die dann zu Hause
Nein,
in der Küche steht, sondern ein größerer...
Also die Nutzanwendungen sind später dazugekommen und heute sind wir so weit, dass wir das Raumfahrtprogramm auf der einen Seite aus humanistischen Gründen vorantreiben. Am Mars, zum Mars zu fliegen, da verdient man zunächst mal kein Geld dran. Aber man erweitert das Bewusstsein so, dass die Menschen der Zukunft, und das sind ja nicht wir, man muss immer den Menschen mit hochrechnen. Man darf nicht sagen, ja wir heute 1999, 2000, was haben wir auf dem Mars verloren? Es sind Menschen, die in 20, 30, 40 Jahren da sind. Die haben
aber
ganz
es
andere
gibt Ihnen
Überlegungen.
natürlich heute auch schon etwas so wie Genugtuung und schon das mit vorangetrieben zu haben.
Man darf nicht mit heutigen Werteinschätzungen, auch mit heutigen Wirtschaftssituationen arbeiten, wenn man an eine Zukunft denkt oder plant, die 30 Jahre
Nee, das habe ich schon
entfernt
mitbekommen.
ist.
Man soll
das
es
muss
machen.
Das muss mit
Meinung.
hochgerechnet werden.
Ja, genau. Aber jetzt wollen